This is not a main thing, really I'm a coder. Coffee stains and in my chains, I am such a loner.
Setting up.
San Francisco places got me slowly taking over. I can't wait to show you that I'm gonna take it over. Nico, beast mode, 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 Nico, beast mode. This is not a main thing, really I'm a coder. Coffee stains and in my chains, I am such a loner. San Francisco places got me slowly taking over. I can't wait to show you that I'm gonna take it over. Nico, beast mode, 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 Nico, beast mode.
Yo, what's good? What's up? Hope your weekend has been good. Happy Sunday. How's your weekend so far? Just need to get this. About to get the first candidate in. Jacob, what's up?
Yo, how's it going?
Good. How about yourself? Happy Sunday.
Happy Sunday.
One sec, just doing a little bit of setup.
All right.
What have you been up to? Been a while since we hopped on.
Yeah, I mean, I'll be honest with you. Just trying to brush up on DSA fundamentals. I think that the last time I was here, I just don't think I had the practice like weeks prior. So now I kind of have like things kind of in my tool belt, kind of ready to go.
Yeah.
So yeah, hopefully I can do better this time around.
Awesome. Yeah. Sorry, I'm just doing a quick setup. All right. Should be good. SB, what's up? So how many LeetCode questions are you at now?
I want to say definitely since I talked to you, I've at least done 2 a day.
Nice.
So I don't know exactly how many that would be, but like consistently, at least 2 a day. I mean, there'd be some days where I would take a break because on top of doing LeetCode, I've been working on like 3 personal projects.
Wow.
And also working. So, but yeah, I would say I've been pretty consistent.
Awesome.
And I would also say that some of them have been repeats just to test my memory.
I see. Okay. Give me a sec. Just setting one more thing up. My chat.
Man, I watched your video. I think it was from the other day about 2026 summer internships already being out.
It's already out, right? It's crazy. Safe attack games.
Yeah. So I've taken your advice just like on the scheduling of things, and I mean I was kind of already doing the DSA fundamentals part, but yeah, I'm just gonna keep that in mind as I'm
Did
going.
that surprise you that they're already dropping? Like the interviews are already coming
No,
up?
I actually already heard had been hearing about this pretty much all July that they're dropping now,
Yeah.
which is kind of interesting, because everybody's wrapping up their internships for the summer and like it's already time to prepare again. So, yeah.
Yeah. Well, you have a long time to prepare, but yeah, it just starts coming out so fast. The big mistake I did when I first graduated, or when I was first looking for internships, is was I started applying in December, and like as you know, like a lot of the good ones get taken up already by that time. So
Yeah, I went ahead and sent in a application to, I think it's called Citadel,
nice.
and they already are. I guess they send everybody out like an assessment.
Oh wow! So you already got the
That's
assessment.
surprised. Yeah, well, I based off of what I've read online, like there's medium and hard level questions, and I just don't think I'm prepared.
Yep.
You know what I'm saying? Like in the
Yep.
next 10 days to do something like that. I think there's definitely some medium and hards that I could do, but I would say like 95% of them are probably just like I'm not going to be able to do without assistance.
Yeah, makes sense. Okay, I sent you a link to where we're gonna be doing our coding.
All right.
Just yeah, sign in there.
And it's all right that I use Java, right? Is that fine?
Yeah, Java's fine.
Okay.
Cool. See, I didn't see any for the top tech. Yeah, I see that, but when I search for jobs, like Google, oh yeah, Google and Amazon didn't really. I don't think those dropped yet, but more of my videos is saying things are gonna start dropping. I don't know when Amazon and Google are gonna drop, but probably within the next couple months. But what you should do is probably just start apply or not applying. Maybe apply for some, and if you get interviews for ones you don't really like, it's low pressure because you can take the interview. It's good practice. If you fail it, it's okay. But the Amazons, the Googles, the Metas, the ones that you really want, if you don't want that to be the first interview you get this recruiting season. You know,
Okay.
you yeah.
Yeah, I that's definitely kind of how I'm taking this assessment that I just got is like I'm going to do it, but by no means do I expect to, you know, do amazing. I'm probably just going to use it like as a learning experience if anything, but I guess we'll see until I do it
Mm,
also.
cool. Let's start
Could
this
be
up.
easy, I don't know. That'd be
Yeah.
great.
All right. Hey everyone. So today we have somebody from Indiana University. So this candidate is based in Indianapolis, has solved 100 to 150 lead code questions. And yeah, that's pretty much all the information I have on them right now. Would you be able to just give a quick introduction to yourself? For yourself?
Yeah, so my name is Jacob McDaniels. I am from, like James said, Indiana. I go to Indiana University, um, and I'm a current junior. So, um, yeah.
Cool. So how long have you been lead coding and sort of how has your lead coding journey been so far?
Yeah, I mean, I think the first time that I heard about Leak Code was probably maybe 2 years ago, and or maybe even less than that. Yeah, probably like somewhere in 2024. I was taking like an object-oriented programming class in C++, and I wanted to prepare for my data structures class, and that's kind of how I learned about that. Um, so yeah, I mean, and I think also there was like a Mario staircase question in a so there's this like free uh, website called EDX, and it has like these free courses online through like all the like big Ivy League schools like MIT and Harvard. And I took a computer science class through Harvard back in 2023, and I think that's probably the first time I was exposed to a leak code esque question. Um, so
Yeah. How has it been working for you? Is it starting to click right away, or some easies and mediums are still a struggle?
yeah, I think my main problem is like I'll get done with maybe a question that, I just needed help with, and I'll be like, "Oh, yeah, that makes sense." And then I'll practice it and I'll be like, "Oh, I got it now," you know? But then not even 5, maybe a week later, when I go back to try it again, it's like there's still some things that I'm forgetting about. And I'm not sure if that's because of like the amount of things where my time and focus is in, or if that's because, I didn't take enough time to really get down like the process. But yeah, I think that in a general sense, like once I, do it, you know,
Hmm. Yeah.
um, I can understand it, but then retaining it is a kind of another thing, especially if I'm moving on to other topics.
All right. Cool. Let's just get straight into. Let's get straight into the first question then.
All right.
So this Q1. What's gonna happen is we're pretty much gonna be given two non-negative integers in the form of a string, and we need to return the sum of num1 and num2. We can't, however, we can't just convert these strings into an integer, like the full string into an integer. We can't just be like, we can't cast 1 1 into 11 and 1 2 3 into 1 2 in like to integer and then just add them. We need to come up with another approach. I'll let you go ahead and read that if that makes sense, and just let me know if you have any questions.
I gotcha. Okay, so as far as a string goes, is like this is integers plural, like a string, like num1 might be like 1 2 3, or are we talking about like just like one of the variables is going to be a string with one number?
So
Or
you're
actually,
gonna
I'm sorry, I didn't see the
yeah, the example.
examples.
Yeah.
Okay, so for num2, that would be 3 separate non-negative integers, right?
3 separate non-negative integers, num2.
Yeah.
Well, it's just a string representation of 123.
Okay. So that's my question is like each variable is going to be one number, not multiple numbers
Yeah,
or
each like
integer.
num1 is one number, num2 is another number, but they're both gonna be in string format. So
Okay.
take a look at num1 and num2. The output should be 1 1 3 4 because if we add those up together, we should get 1 3 4.
Okay. And then it says that you must solve the problem without using any built-in library for handling large integers such as big integer. So that would be like a case if I'm dealing with like long data types, or like am I supposed to have like a case where I need to handle like larger integers like longs?
Good
Is that
question.
is,
So you're asking, do we have to deal with integers that are like long integers?
yeah, what would be considered, a long constraints?
Well, I'll show you the constraints. So the num length could only be 10 to the power of 4.
Okay. As far as built-in libraries, right? So, because I wonder if I
So
can
the
split
integer
these.
could be 10,000. The integer could be 10,000 length.
Right.
So it could be like 10,000. So it's pretty large.
Okay. Um. Okay. I also have another question. So, as far as like built-in libraries, am I not allowed to turn these strings into char arrays? Is that would that meet that condition?
Pretty much the only thing what it means is you can't write a solution like this. Result equals cast to an int num1.
Okay. Right.
Anything else is fair game, I would say. Like you
I'll
can't just
be
cast them to num or long or whatever and then return that.
right. So hmm, okay. So I guess what I could do is I could just start with just getting some input out there. Right.
What are your approaches that you're thinking?
I'm gonna be completely honest with you. This seems like the only path like that I think I might have is to try to work with some kind of char array and possibly get that back, like maybe concatenated into like an integer. I mean, that's the only thing that I'm kind of thinking here. Um,
Could you explain why you need, or once you get into a car array, what you would do?
Um, so we would break that into a char array, right? So then we would have like for example, this input here would be 1, 2, 3. So then we would have an array of 1, 2, 3, and then what I would need to do is take that array and turn it into an integer somehow, which I'm not entirely sure how I'm going to do that, but maybe.
Turn it into an integer so you can get something like 1, 2, 3, and then eventually add them.
Right. But I'm not entirely sure how I'm going to get there. Because what I'm thinking is that like concatenation only works with strings. So with that being said, I'm not really too sure. I mean, we could iterate over a char array and do something that returns an integer, but I'm not sure syntactically what that might be. But yeah,
But then we just had the numbers 1, 2, and 11. How would we actually add these up to get 1, 3, 4?
Well, you have the two variables, so we would want to, I guess, get them back into. So we have our string variables, so we would need two new variables eventually that are integers, right? So that we can be able to do math operations. Um, as far as how we're going to get there, get these converted, I'm not entirely sure, but that's how we'd be able to add them, eventually add them up.
Okay, but what happens if they're a list? If, like you mentioned, we converted them to a list of integers.
Yeah, I mean, from that standpoint, Yeah, I mean, if we had a char array, I guess we could turn that into an array of integers. Um, from there,
Well, like, I don't- well the I'll tell you the solution isn't turning them back into integers because then pretty much all we'd have to do is just add them together. So it's pretty much the same as I mentioned casting it, but that just takes a few step, like an extra step.
yeah, I'm gonna be honest with you. I'm not really too sure how I'm gonna get these um, to where they need to be so we can add them. Um, how without using casting, I mean, how would I
Or pretend these
accomplish
are integer. Pretend we can only cast one digit at a time. Pretend these are integers now, and then we have num1 like this. Pretend we had two arrays that describe. Pretend we have two arrays that describe two integers. So this describes 1, 2, 3, and this describes 11. And we just want to print a result of 1, 3, 4. How would we do that?
Oh, okay. Yeah, so that seems like an interesting scenario. I guess you would need to kind of understand the amount of indexes in both the arrays and then kind of get them lined up, right? So that we can add three with, um, or I'm sorry, index two with index two, and, or I'm sorry. So basically, we need some way for this to happen, if this kind of makes sense. Like, it needs to be lined up like kind of elementary addition.
Mm-hmm.
I guess if we know like the size of each array, that way we can get them lined up the way that they need to be, if that makes
If we know the
sense.
size, they won't be the same size all the
Right.
time.
So,
Yeah.
for example, if like this is an array of size 2 and this is an array of size 3, then what we would need to do is say the very first index of our second array needs to be added to index 1 of the first array.
Okay.
So the I think one maybe like easy solution could be like if we have something like that, um, maybe we could add like 0 to the front of num2 and then add, right? Like indexes, if that makes sense.
Yeah,
Like,
that makes sense. So like add some padding here, so it's 0, and then it lines up.
right. And I guess that is also dependent on the sizes, right? Because if num1 is maybe 5, right, and this is still 2, then we need um 3.
Yeah.
So 5. Oh, so we could just subtract the indexes, and whatever that difference is that we pad the front of the smaller array.
Hmm. Um. What would be the runtime for adding elements to the front, like padding here?
Probably O of n. That'd be
Hmm.
really slow. Um, as far as making that better, I'm not really too sure because the solution is kind of like, hey, we're just gonna add these in here. Um, but I guess without traversing, right? If we don't have to traverse, then it could be like O of 1, right? We don't have to traverse the array.
If we don't have to traverse the array.
Yeah, so like if I know the difference, right, then I could just like out in the open say, hey,
Yeah,
like we're
it
gonna
makes
put at
sense. Let, let,
index.
let's talk. Let's assume they're the same size, like two. So, um, we have about like 6 minutes left for this question. So maybe write out some code where you're adding two numbers that we could assume they're already in arrays, but then assume that they're the same size as well. So we don't need to deal with the padding at all.
Okay. So I could just already have an array, or
Yeah, we could assume if you come down to the code here, we could assume the input. Like write me some code that it could add like two, and they're gonna be the same length.
okay. Okay. So I think the base case for this maybe could be that if they're equal, then that what we
Let's
can
assume
do.
that they're actually equal. Yeah,
Okay.
just assume that they're actually equal. Don't worry about that part. Just write the function that maybe we have like a int num3, like an integer array, and then add these, basically generate me something like 3 and 3. What's 11%? Yeah, 33. Because afterwards, all we need to do is convert that to a string and we're good.
Okay. Um. So definitely, this is probably gonna end up being O of n, at least for the brute force. I'm not really too sure how we could improve this at the moment, but I don't even need that, I don't think. All right, so that's probably
Num3
or
0.
I'm sorry. Give me a second.
Yeah, and then like write out some test cases to see if it passed.
Probably I. Um, yeah, so that's probably what I'm thinking here is that um, at because like you said, we want this to end up looking like this. So what we're gonna do is that at each index add, and then the result's gonna go kind of lining it up, right? So if that's the array like this, the first time through the loop, 1 plus 2 is 3, and that's going to go in index 0. We're going to go to the next one. 1 plus 2 is 3, and all of these would be index 1.
Okay, how would we test the code?
Well, I mean, I could check, right?
That's good.
Well, I mean, we could do a for loop, and every time through, we could, print off the index. But I wonder, if instead of that, we could do this as well.
I want to see what the final num3 is gonna be. Like what the final.
Like total.
Let's return the output. Let's return like an output here.
Okay. I'm sorry.
Well, what if the num3? Okay, just go ahead. Just print that. See if it runs. Error.
Am I missing something here? I'm kind of confused. Why this is?
What does the error say?
It looks like somewhere a semicolon is missing, but I don't think that's actually needed here. So. Oh, right. Okay.
Now you're gonna have to run your function. How do you make that function run in the main function?
Right. So.
So what's happening now? It says index 0 out of bounds.
Right. So I think because num3 is empty, we're not getting anything. So I don't know if populating it with 0 is going to make a difference. I don't really think that. maybe it's because of this num3 at I, because there's nothing in it yet. I'm not exactly
Well,
sure.
you're so no wait. What happens when you instantiate an array in Java? It creates an array, right, of a fixed size. So it's creating an array of size 0.
Okay.
So it's saying index out of bounds. That means you're accessing an index that's out of bounds because it's an empty array. Nice. Okay.
Oh, I'm sorry. That's a list. I don't know what I'm thinking about here. Sorry.
Okay, this creates an int of what size?
I guess we could just say, just for this case, right? Since we know that they're the same. So
Okay. Okay, now like prove to me it works. How are you gonna prove to me it works?
so if I run, I guess I'm getting returned some kind of, right. So I don't, maybe we need another, like, something that says like print array, like some kind of method, right, that does that. That might be what's going on right now. I don't think we can directly print an array like that. That
Print
might be
array.
an issue.
So how would we print an array? Like how can we print out the contents of num3 so you could prove to me that your algorithm is working correctly?
Right. So just as we added right up here, I mean, it's kind of the same thing. So I guess that would it might be easier for every time through the array to or we just do this. This is what I'm gonna say. And right.
Okay. So
And I'm
alright.
sorry, we don't need to do a new line. We'll just print and it'll
Yeah.
should come back as 33.
Nice. Okay. So now where will your algorithm break even with 2 digits?
So you're asking where will it break? Like outside of the fact that like num1 and num2 are the same size?
Yeah,
like,
exactly.
variable
Where
sizes?
can it break? Yeah.
Yeah, so like for example, if num2 was like of size 3, then I mean this 100% isn't going to work because they don't line up correctly. So you can't really do that
Yeah.
unless
I mean like
beforehand we make padding that does
yeah.
in fact
Like,
do that.
yeah. Like I said, if we assume both of num1 and num2 are the same, right?
Okay.
So where else? How can it break besides that? Essentially.
So if we know that num1 and num2 have the same size, you're asking me in this case, how else will
Where it wouldn't work? Where would it not work? Still. Like I'm basically asking you to think of more edge cases than what you mentioned. So you thought of one edge case, which is different lengths. You
right?
already
So
said padding. What are some other edge cases?
Yeah, so if like the okay, like empty arrays, right? So if they're empty, we're just gonna return 0, maybe. Or
Okay.
if
What else?
I guess if both, right? If both are empty, then we return 0 for sure.
Okay.
Now
What
if
else?
one is empty, then we're just gonna return the contents of whatever array is not empty. So if
What
you know
else?
num one,
There's another one that I want you to find.
there's another one. Okay. Um.
Like you have two right here.
So we definitely have like a null case. We have a case where they're different lengths. We have another case where they're both empty. Um. It could also be the case where like we can't use int maybe. Or no, I mean, I guess with the solution,
Okay.
the way this works, like long.
Pretend we have something like this.
Oh, I see. Okay. Right. So carrying over in addition. So if we have a case like that, then we need to figure out some kind of way to add to, or yeah, we need to start from the end of the array. If we have probably, I mean, it would be like, that would be kind of like complicated too, that case, because, 5 and 6 equal to 11. So that would be like probably one of the first cases where we see something needing to carry over. So
Yep. I want to handle that carryover
4,
case for sure.
I mean, even the case like 9 plus 1. So I'm not really sure how I would account for that either. Because, I mean, almost all of the numbers 1 through 9 can be capable of carrying over.
Can you say it again?
All the numbers 1 through 9 are capable of carrying over. So, like 1 plus 9, 2 plus 8, 3
Yeah.
plus 7.
Okay, let's just go
So,
to the basic case then. 2 plus 10. Or 2 plus 8. How would we handle this case now?
um, so, and you're saying that, for this case, it would also be the same size, right? So 2 and 8.
Yeah, they're the same size, but the final
Okay.
result is going to be 10.
Yeah, so I think what I would probably do is that if the result, um, like if an index's result is greater than 9, then we need to add to, like, so, and I'm going to say the next index, but what I mean is like if we have a for loop that starts at the end of our array, right? So the next index would then be added whatever like the remainder of the first like column is.
Hmm. Okay. All right. Let's see what's the case. Okay, sounds good. Okay, we're about at 40 minutes, so let me stop that about here. 35. And then let's just work through this question so you have like some. So, okay. So I think, so what I saw from you in this interview would be, I think you just have, you still have a lot of practicing to go. I think you'll get to it with just enough practice. But first off, I think just being familiar with the language and just getting more comfortable with the language. So, for example, being able to easily catch errors, such as initially you're sort of creating the nums like this, And when you're trying to add it, we were running into a null pointer exception because it's trying to access like the 0th index, the 1 index, whatever. But this is empty. So that's why you're getting the null pointer exception. Let me run this. See. So you'll see index 0 out of bounds for length 1. So I think just being familiar with the language, and one way to do this a lot simpler and what you were kind of doing is using the array list instead, because the array in Python or the array in Java is not dynamic, it's static. So like for handling the carryover, that's where the issue where you could run into the issue, because I'll just go through how you could actually solve this question. So like the solution I was expecting was we have num1 here, right? And you're following this so far, right?
Yeah.
So the solution I was expecting was we have num1, num2 as input. What we do is we would convert this into, it could be an array list. It could be it could be a list of integers or even just a list of strings. Doesn't even matter right now. But pretend we just convert it to a list of integers right away. And pretend it was
that
even.
would have been fine. That would have been okay with the built-in library portion.
Yeah, that would be fine. I pretty much said you just can't do here. You can't just convert the whole string into a long or int and then
Like
just add
casting.
them.
Okay.
Right. So once we have num1 and num2 as a list here, let's go with this. We would just build a num3. So pretend, actually let's say this is 21, right? We know that we need to pretty much add or start with the least significant digits, and using elementary division, 1 plus 9, we would just add this. 1 plus 9 equals 10. If it's over 10, then we have to carry 1 over, right? That's how the division or addition works. And then what is this? 11, 12. Then that's 12. This would be 2 and another carryover. So what we could actually do is just reverse both of these numbers so that we get the least significant digits at the end, at the start. Now we just do what's 1 plus 9? 10, which is 0. And we maintain some sort of carryover variable. So we do a carryover here. What's 1 plus 2 is 3 plus 9 is 12. That's equals 2. And then we get to the end and we have another carryover. If we have a carryover and we get to the end, we just attach that to the end. And then reverse that again and get 1, 2, 0. So yeah, 99 plus 21 is 120. So that would be sort of the solution here. Does that make sense?
Yeah.
Yeah. So oh, go ahead.
Basically, if whatever array has the least significant digit, we're going to reverse it and then get that solution. And then when we print it out in reverse.
Well, okay. So what even do you get what I mean by what the least significant digit is?
I mean, I guess not. Go ahead and explain.
Yeah, least significant digit is just the first digit in a number. Let me see if I even what is least significant digit. So basically, the least significant digit is the rightmost element, or is the rightmost digit. So here it'd be 6, here it's 7. Because when we add, we need to start with the least significant digit, or we need to basically work from right to left, right? So if we're doing elementary division, we don't start at the front. Well, we start at 6 plus 7. Then we go 5 plus 7. Then 4 plus... Right? Does that make sense?
Yeah, for sure.
So yeah, that's why you would reverse them. That's why, and someone asked in the chat, is it necessary to flip the array? It's not necessary to flip the array, but it does help, because then once you reverse the arrays, So 4 plus 6, because if you want to add 6 plus 7, if you reverse the arrays, it lines it up perfectly. So we're at 6, 5, 4, and we have 7, 7. So now we just need to iterate from left to right and just start adding those together. So 6 plus 7 was 13. Would it carry over?
So you would reverse the. Okay, could you go to explain that? Because I know in the last one, right, we had similar sizes, but in this case, you reversed. Did you reverse both or just one?
You would have to. Okay, what would happen if you only reverse one?
I guess that would be the case that you're writing right now.
Well, if you reverse 77, it's a palindrome, so it's
Right, so that's why I'm
reverse.
asking though, is it for both cases when we have differing sizes of arrays, or is
Okay.
it
Let's look
just
at this. Let's look at 4, 5, 6, and 5 2. So, would we have pretend we wanted to compare the least significant digits, the ones on the very right? How would we get it into a state where we're comparing both of them?
so you would need to reverse the first array,
Okay, then we get 6.
6, 5, 4.
Okay, and then
I
like
think that
it,
5, 2 would then stay the same in that
well
case.
then okay, then we'll be doing like 6 plus 5. 6, we'll be adding 6 plus 5 here. I
Okay.
think just go
So
back, just I'll send you over this question. I think it's gonna be hard to like walk through it. Like I would rather have you sit down and think about this question. It's a good question to learn and just just try it out yourself. Now that you gave it a shot, I'll give you a small hint. Um, yeah, just I'll send it over to you.
okay.
But I think yeah, I think just more practice. It's good that you're starting now. Just start off with some of the easy questions and just make sure you can even implement. Try even just implementing a lot of them from scratch without lead code. Don't look at the answer right away and don't copy or paste any code. Just go try to implement it. Try starting with this one first.
Okay.
Mm-hmm.
Yeah, I think this problem definitely threw me off with this. You must solve the problem without using any built-in libraries. I think I probably spent a little bit too much time thinking about what that exactly meant, as far as utilizing certain syntax. But yeah, I definitely think that there's certainly some cases in here that I'm not sure.
Mm-hmm.
Yeah, I definitely need more practice with this question for sure.
Yeah, I'll send it over to you. Let me give it to you. All right, cool. Thanks for taking the time out to interview. Let me know
Yeah, thank you.
when you're practice that one a little bit and maybe we can book in like a month again, see where you're at.
Yeah, yeah, for
Cool.
sure.
All right, man. Have a good day. See ya.
All right. Thanks, James. Bye.
Bye. No problem. If the arrays weren't reversed, we just iterate from the last index rather than index 0. But pretend, Noor, that makes sense, but pretend we're adding two big numbers like this. Like we can start 2 pointers there. And just make them go backwards, yeah, for sure. But honestly, it's easier to just reverse them, do the elementary addition, and then reverse it again. That's I find that easier. I mean, you could make anything work, but for me that's the cleanest. Okay, we got more people for sure. We're gonna keep running this. Does that make sense, Noor? Next person has around 300 lead codes. Okay, give me a 5-minute break. 5-minute break. 5-minute break. Okay, Noor, check this out. Pretend num1 num1 equals here. Num2 equals 2, 2, 3. So if we want to do the elementary addition, what we can do is we could just work from the back of both of them. I mean, it's probably just the same. I just like for me I just like to reverse it, but let's see. It would probably be the same, but then you would have to think backwards a bit. So what's 3 plus 1? 4. Then you reverse. Then you move this back, and let's see how a carry would be. Pretend we have 9 plus 2. What's 9 plus 2? That's 11. We have like 1 with a 1 carry over. What is it? 4, 6. We get 6 here. And then if one of them reaches the end, we just start appending all. We just keep going backwards here, appending all of them to the back. 2. Oh yeah, actually, yeah, but then we still need to reverse the answer at the end. So we're still doing some type of reversing if we work backwards. Because this is turning it backwards. I mean, because we don't know what the size of the final array is going to be. We can't predict that because it might be one larger or it could be the same. If we wanted to initialize a big array of just a bunch of zeros, that with like 1 extra in case it carries over, that could work too. But yeah, that's why I like to reverse. Why I like to do the reverse. Does that make sense, Noor? Why not convert it to string and keep appending? Why not convert to a string? Well, you want to keep it in as array because appending to a string, pretend we already have 1, 2, 3, and we try to add a number. That's O(n) time. I have a video on that because strings are immutable. So if we try to implement that where we keep adding to the string at the end of it, it's gonna lead to a O(n) square algorithm. Okay, we're gonna get to the next person. Check out the question and try it for yourself, and then let me know what you think. There's a lot of different ways to do this question. I'll be right back. Like 2-minute break. 2-minute break before the next guy. Mars, you ready? So I've been try it out. Let me see. There's multiple ways to do it. I'm not saying you're wrong. I mean, I'll be right back. Alright, I'm back. So I'm gonna send you a couple of videos. Yo, what's good? What's good? What's good? Sybin, make sure for recursion, make sure you understand the call stack. Lastly, no problem. Got you, got you. Mars, what's up?
What's up? Can you hear me?
Yep.
Yeah,
Shit,
good.
talk. How you doing today?
Good. What about you?
Pretty good, pretty good. You just tuning in? How was the last one? Any thoughts?
The last one, the last guy? Yeah.
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 Did you understand
yeah.
what the solution would be for that question?
Yeah. The addition of two strings, right?
Yeah.
Yeah. Just looping from the back, keeping carry, and just changing each letter from int, like using built-in, but just not for the whole array, and yeah, reversing the results at the end.
Nice. Cool. When did you start tuning into the streams? Was it lately, or you've been here for a while? I feel like I seen your name maybe before.
No, yeah, 2 weeks, I would say.
Oh, 2 weeks was when you started seeing my videos?
No, the videos was a bit longer, but I cannot catch the streams.
Okay.
But
What
yeah,
time is it for you there now?
It's 5. It's 5 actually. 5 p.m. I'm in Panama for the summer.
Nice, nice. Cool. All right, let's just get this started then.
Yep.
All right, I'm gonna start. Hey everyone, so today we have somebody from France. Nice. Panama for the summer. France otherwise has solved 300 LeetCode questions. I just visited France for the first time a few weeks ago, early July, and I loved it. It's one of my favorite countries for sure. Paris. I was in Nice. It's a beautiful country.
Yeah, the south is great.
Yeah. So where are you from? Are you from? You're living in France. You did all your school there. You're doing university there.
Yep. Yeah,
Nice.
and I'm actually like for my summer internship, I'm in a startup in Panama for like 3 months.
Nice. So, what is it like going to school there, and when it comes to job opportunities after you graduate?
Well, it really depends. I would say it really depends if you're like around Paris or not. As I'm not really near Paris, like my college isn't near Paris, it's more like in the Alps, and like all the better schools are around Paris, and all the like FANGs and all the big tech companies are mostly recruiting from Paris. So yeah, it's good, I would say, but if you want to really target big tech companies, you have to seek like other like Paris or other countries in Europe.
I see. Okay. But pretty much since it's in the EU, can you literally just work in whatever country you want?
Yeah,
In the
yeah. I
EU?
mean, it's really easier to work in Europe compared to like USA as the visa and other stuff. So yeah, I'm aiming for Dublin if I can for my next internship that I'm seeking from Waiter. But yeah, I'm basically can work everywhere in EU.
Okay. So I'm just curious, what is the algorithm or lead code community over there? Is a lot of your peers also doing lead code and know about lead
Not,
code, or not really?
not so much, not really. It's yeah, I would say it's most of the US sector, I would say, which really grinding lead code. But yeah, in France, it's more like I wouldn't say doing projects, but a lot of people just rely on the college and what we learn in school and doesn't really push the thing in projects or more like in lead code. Yeah, I don't know
Okay.
many people that are good in lead code.
Okay, so most people, like when they're looking for a job, they just apply with what they
Yeah,
learned in school, not really doing side projects or not really doing lead code during
yeah,
school. Okay, cool. So
I would say.
what got you into doing lead code then?
Yeah, because I watched a lot of video, I would say, on the more on the US sector for guys from like um, Carnegie or other like top school like that, who were like, oh, I need to go and lead code to land a FANG job, and I was like, oh yeah, I need to do I want to have those type of internship at like FANG companies or big tech, so I need to go and lead code also.
Mm-hmm.
Whether it's like in the US or in Europe, I think um, all the companies are basically asking for lead code. So yeah, need to be great.
Yeah. So how are you feeling with it right now? You've done 300 questions. Are you pretty confident if I give you any question that you'd be able to make some sort of progress on it?
Yeah, I would say I covered pretty all the basics. There's still like I would say the most fear one dynamic programming that I have like the intuition to see it's a dynamic programming problem, but like really implementing it and provide not the mathematical proof, but like yeah, just proving what I'm doing is right. It's a bit complicated, but yeah, most of the patterns I would say I saw them at least one time.
Cool.
And yeah, in my grading, I would say I'm not just focusing on like the numbers of problem I'm doing. I'm also like doing active recall on all the problem I've done to see if really I understood the patterns and I can do it like 1 month later.
Awesome. Cool. All right. So what language do you want to code in?
I code in Python.
Okay. Nice. I like that.
Simple.
So, all right, we're gonna get to the first question. I'm gonna post it in here. So we're gonna be given a root of a binary tree and an integer target sum. We just need to return true if the tree has any root to leaf path, such that if we add up all the values along the path, it equals the target sum. A leaf is a node with no children. So that's all I'll give you right now. And I'll let you go clarify and figure out how we're gonna get this done.
Okay. Where can I find the CodePad link? I
Oh
don't
shoot!
find it.
Give me a sec. Give me a sec. Give me a sec. I realized I didn't send it to you. Where's Panama?
Okay.
Is it in like South America
It,
almost, or not?
Yeah, it's really in the middle between like
Nice.
yeah, USA and South America, I would say.
I see. You have the link, right? Or you just log into the link.
Yeah, I'm just putting in my email address. Okay, great. Can you see what I'm typing?
Yep, I can see.
Okay.
Okay,
Okay,
I'll let
let's
you read
read
it.
this. Given the root of the binary tree and the integer target sum, return true the tree as a root to leaf path, just adding up all the values along the path equal to target sum. Okay, a leaf is a node with no child. Okay. Okay, so we have a binary tree, not a binary search tree. Okay, an integer target sum. Return true if the tree has a root leaf path such that adding up all the values along the path equal target sum. Okay, I have a few questions within this problem. First, concerning about the node of the binary tree, can we have like any integers and can we have duplicates in those nodes?
Duplicates, as in, what do you mean by that?
As in like I have like the root of 3 and down the path, I would say I would encounter 3.
Yeah, it could. It's free. Any node could be any number.
Okay. Any number. Okay. Any node. A leaf path. Okay. Do I have like a minimum number of nodes in the binary tree, or the binary tree can be empty?
Let's assume that it could be empty. Yeah, it could be empty.
Okay. So how the nodes are given? Is it like a classic thing like in LeetCode, like a data structure with a class with a left and right and value?
Yeah, we can assume that we can create a class or assume that the class, like we have a class.
Yeah, class node. Okay.
Yeah.
Okay.
Left, right.
And value. Okay. So we would have. So we just need to return true, right? Okay. Which has a root on the path. Okay. Basically, if we can take any example, let me draw like a binary tree here. Let's do a very simple example like this one, and my target is I would say 3. It's good, it's great. We do have a path going from 1 to the left and 2, not children here, so that's a leaf, so we have a path, and we go on the right, we have 4, that's not a path, but yeah, the path exists, so we return true. If we have 4 also works, but going down to the right. Okay, and any other target sum wouldn't work. Okay, so let's maybe try to code it up.
What's going to be your approach?
Yeah, my approach would be to do a DFS, keeping track of the path, and at each step, adding the actual node value in the path, I can. Oh, right. I can just keep track of an integer because the path would be like, I don't care of the node I'm visited. I just care about the sum I'm at. Yeah, just going down to the tree, sorry. And when I'm at any leaf node, I'm just checking, am I at the target sum? If it's good, I'm returning true. If it's not, yeah, I'm just keeping visiting, and if I'm seeing one valid answer, I'm just returning true. And basically, I need just one answer, so I can do an OR between all the solution I would see.
Okay.
Yeah. Okay.
Sounds good. Just go ahead and implement.
Just do like root to leaf path exist. Exist root to leaf. And we take the root node. That would be like class node. Let me just call it real quick. Left, right, and a value, which are node also. Okay, let's just not bother with that. Left and left. Okay, and taking a root, that's a node or an optional node, but yeah, it doesn't take care here. And the target sum, which is the int, and we basically would return a boolean. Okay. Okay, our base case would be if I don't have a root, as you mentioned. If not root, basically just returning false. Okay, and now I will do like a helper function, like DFS. What do we need to track? We need to track the actual node. That will be a node, and the current sum that we call S would return I don't know if I'm returning none and updating the global value or actually returning the boolean. I'll just return none for now. Okay. Okay, and the answer would be at first false. I'm gonna do my DFS on my root and return my answer. And basically what I'm gonna do, if I'm at, my base case would be if I'm at one leaf, so if I don't have any children, so if my node doesn't have any left and doesn't have any right, I'm checking if my current sum S is equal to my target sum. If that's the case, I'm putting my answer to true and just return right here. Well, doing that, I need to put it non-local because that would give me an error otherwise. And what basically do I need to do? I need to go, keeping to my example here, I'm at 1. I need to, sorry, just doing that. Okay. Just going left and right with the new values. Okay. So just going left, so DFS on my node.left if it exists, otherwise it would be complicated, with my S plus node.left.value, and basically doing the same on my right and right. And okay, doesn't return anything. Okay, let's do a dry run with my little example here. I'm starting at 1 with a value of 1. I go on the left 1, or my if statement is false because I have some childs. At 2, do I have some child? No. What are my current sum? It's actually 1 plus 2 is 3. My target is 4. It's not. I return. I'm going back to 1. I'm going to 3 with the sum S of 4. Is my target? Yes. I'm modifying my answer here, returning, and going back from my call here, returning also. Okay. I think this code would work. I can see a little optimization, just checking like if my answer is true already, I don't need to find other path. Just putting a if statement at the beginning of my DFS. But let me think of more edge cases. If my target sum here, okay, can my target sum be negative here? Oh yeah, it can, but I don't care because you said that the nodes can be any values, so the sum also can be negative. Okay. Yeah, I think that would work. I can't find any more edge cases.
Let's do a dry run.
Yeah.
So do a dry run on a small example.
Okay, let's maybe take a bigger tree here because it's not really good with like only 2 answers, 2 values.
Yeah, let's bring this down over here so we can like So when you walk me through, I see.
Yeah.
We could just work through a small example. Maybe the result is result is 5.
Okay. So we have a root. The root is 1 here, so it's not returning. We are defining our answer to false and going from the DFS here, sorry. So we're calling DFS on 1 with value 1. What are we doing next? We are checking if we have child. Yes, we do have 2 and 3, so we're going to the left here with the DFS. So we call DFS on 2 with some 1 plus 2 is actually 3. Okay, we have 2 here. We're checking if we have child. Yes, we're going also to the left again with 4 and some 6. We do not have child here. So S is not the target sum, so we basically just return and go right here and go to 2. DFS on 2 with the target of 5. Yes. So we had 2 here. We don't have any child. It's the target sum 5. Yes. So we put our answer to true. We'd return and just going back to 1 after and going to 3, it would be 4. And what it doesn't is not like the 5 attended. So we're just returning.
Nice. Okay. All right. I think it makes sense. Let's move on to the next question. Good job.
Yeah. Okay.
So I'm gonna give you the next question. So this is the next question. So
Okay.
we're given an n by n matrix. We need to return all elements in that matrix in a spiral order. So
Okay.
I'll just show it quickly in the drawing what that would look like.
Mm-hmm.
Just hop in the drawing. So pretty much we just need to go 1, 2, 1, 2, 3, and then go down this way. And go down this way. This way we get 6 to 9. We pretty much need to just traverse it like this. Like spiral.
Yeah. Okay.
I'll put in a few examples.
Okay, we can all the elements in spiral order.
Does that make sense?
Yeah. Okay, drawing mode. N by n. Okay. So okay, n by n matrix. So it's not a square, it's like a rectangle, like vertically or horizontally, doesn't matter. And return all the elements in the matrix in spiral order. Okay. So this one, copying it in the, how can I, okay, I can go to enhance this one like this. Okay, like the spiral order for this 3 by 4 matrix would be like 1, 2, 4. Yeah. And after 8, 12, okay. 11, 10, 9, yes. 5, and after 6, 7. Okay. Great.
The answer is literally this right here.
Yes. Okay, so this square, like the first example you told me, is a bit easier, I would say, than the rectangle one. But I mean, we can deal this out. My first intuition would be like to count in terms of layers, I would say. like for the input, for the first input you told me, it has like one layer and the 5 being the only element in the second layer. And for the second example, we have also 2 layers. Let me draw them in like another colors, like the first one here, and after the first one here, the second one here, sorry. So the difficulty here would be to just traverse the layers in the good order, I would say. Okay, so it's gonna be pretty heavy in loops, I would say. Let's just start designing the function, like just pivot order. That would return, give me a matrix, which is a list of int.
So what would be the approach, sort of?
The approach, I think, would be to first find the number of layers, which is, I think, for the square example, that would be just, we have 2 layers and we have like 3 by 3. So it would be like 3 divided by 2 and rounded to the next integer. So that would be 2. And for any m by n, that would be like the minimum, I would say, the minimum divided by 2 round to the next integer. And here we have 3, and yeah, divided plus 1 would be 2. Okay, if we have another thing like
how would we
5
loop
here,
the last layer? How would we actually like capture all the values in that layer?
yeah, I'm thinking if I'm doing like 4 loops for each layer, or if I can manage to do more easier approach. Let me think. I will need to go like right here. After I need to do only those 2, not repeating the 4. I think that's a problem I need to handle. After the 11, 9, 11, 10, 9 here, not repeating the 12, and here I just need to take the 5, right? Not taking the 1, not taking the 9. So yeah, we'll keep track, I think, of layer I'm currently on, which is at first 0, 1. Yeah, no, I will maybe in the reverse order, like, no, let's just take 0 and 1. I'm just taking the first row, traversing it. After that, taking the most outer column here, not taking the first one. I mean the ith one, because we are in the ith layer, so not just taking the first one. After that, going all to the end minus the number of layer plus 1. Or yeah, we need to do some calculation to not repeat ourselves. And okay, doing the same thing like reverse, basically.
Yeah, it makes sense. Like, you want to go through layers. You want to do it in layers. I think you have the general direction. Let's go ahead and just try to implement it and like work out the kinks as we go.
Yeah, I think I would have some index issues. That's the problem, but I try not to. Okay, so let's first calculate the number of layers. That would be, let's just take the dimension first. That would be would be the length of the matrix, and would be length of the first matrix. Let's handle the case that if matrix, if we have like no matrix at all, let's just return like empty list. Okay, we have our like okay list. Okay, the number of layer would be like the minimum of n and m divided by 2 plus 1 here. Okay. Okay, well, what we need to do, we need to look for layer in layers, actually. what we need to do? We need to do the first row, the first column, and the second row, and actually the second column. Okay, let's create our answer output, and we're coming at the end, so it's all right. Okay, our first column, what is this? It is like we are starting from the index 0 at first, but because we are at layer 0, so we are actually starting at layer. When are we ending? We are ending at the n, so the n, that's the length of the first row minus layer. So it's like n start happen for I would say I range start to n plus 1.
Makes sense. Makes sense.
Okay, what's actually the coordinates that we are on? We are, let's just call it grid. Matrix is a bit long. Okay, it's actually the 0, but it's because we are at the layer 0, so it's actually layer here and I here. Okay, that's for the first row. I think we're starting at layer, so it's 0 and ending at n minus 1 minus layer. Okay, n minus 1 is 3 minus 0, it's 3. Okay, we are being greatly through this one. Okay, now we need to do the first column. What's the starting point? It's actually layer plus 1. So we're going to do for I range layer plus 1 here. And after that, we need to go all the way through. It's the same thing, n minus layers, I would say. N minus 1 minus layers. And we just append it. So what's the matter here? It's grid of I. It's the number of column minus the number of layer we are on. So the number of column here is n minus layer. Okay, just clean this up a bit. Here, okay, now the second row. So this part here is good. It's a bit messy with all the blue. Can I clean it a bit? How can I do that? Yeah. Oops. Okay. So now I need to do the down layer here. What do I need to do? I need to start from the end. Okay. I'm in range. Okay. So my I here would be n minus layer, and I will go through 0. So it's because I'm at the 0 layer, so it's layer. Okay, I forgot the in, and I'm actually appending the grid of n minus layer here. Okay, let me think about it a bit more because I don't want to mess up everything. It's actually m here. M is the number of row do I have. I have 3 row. I'm at the layer 0. Okay, maybe a -1 here. And okay, everywhere I basically do m, I need to do some -1 to avoid the index error. I'm at index 0. My column is m-1, so that's the right one. And I'm getting the I from m minus layer to layer. Okay, m minus layer. I'm at layer 0. Okay, that's a problem here because m minus layer, I would get an index error, of course. But I need to start from the 11 here, not the 12. If I do like this, I will start from the 12. So I need to okay, let's start at n minus 2 here. Okay, that will work for now. Yeah, maybe. Oh, yeah, good catch here. Image layer, not the in layer. Okay, that's. I'm just gonna put a to-do here to verify the n minus 2 minus layer. I'm not really sure. Okay, and let's maybe do the last color to maybe do some dry run after.
Yep.
In range, okay, so let's suppose I have this booked in. I need to find basically only the 5 here, but more in other case that would be more complicated. But here I need to basically loop from m minus 2 also, minus layer, yeah, and going from this one to actually layer plus 1. No, let me think about it, because here I may need to do like, okay, here when I'm doing some backwards, I may need to do like with I steps, like -1 steps. Okay, let me think about it. Let me calculate this. Okay, m is 3, 3 minus 2 is 1, so I'm starting at 5. Okay, going up until 1, 0, 1. Okay, with -1 step. Okay, let's just add another to do here. Verify the range. I'm not entirely sure. But here the I is only here, and I need to fix the actual layer I'm on. So it's basically layer here, right? Let me think about it. If I'm here, layer will be 1, layer is 0. Yeah, it's actually layer here. Okay, let's maybe do a dry run because I think it's a bit messy with all the indexes.
Yeah, let's do a simple case. Let's do.
Yeah.
Let's just do like 1, 2, 3, 4, and then just 1, 2, 4.
Yeah. Okay. So m and n here are 2. Okay. So how many layers do I have? I have 2 divided by 2, which is 0 plus 1. I have 1 layer. That's right. Okay.
2 divided by 2. 2 divided by 2.
Oh, okay. Yeah.
Oh yeah. 2 divided by 2.
Yeah. The plus 1 here would.
Plus 1 plus 2.
Yeah. Indeed, that's maybe a mistake here. Why do I need the plus 1 here? Oh yeah, because I didn't code it what I said. Maybe just some here. Let's round it. Okay, math. Okay. Okay, that would give us maybe convert it to an int. I don't know if say convert to int natively. Okay, that would be good. Would it handle also the rectangular case? We have like 3.
2 divided by 2 equals 1. Ceiling is 1. Yeah. Okay.
Yeah, I think it's better right now. Okay, so we're just looping like basically 1 time. Okay, for 0 to 0. Okay, so layer 0 here. Okay, I need to catch first the 1 and 2. So we are looping from 0 to 2 minus 1 minus 0. It's 1. Okay. 0 to 1. Yeah, maybe not the -1 here, because we wouldn't catch the 2 actually. And just going from the layer, so it's 0, and I just going from 1 and
Well,
2,
what's
0 and
M
1.
here? M here is 1.
M is
Minus
actually
0.
2 here. M
Yeah,
is
okay. M is 2.
the number of column.
Okay, so here we're looping from going from the range is 0 to 2.
Yeah,
Okay.
basically, just doing 0 and 1. But here it would be n. It doesn't matter for a square matrix, but yeah, it's basically a row here. Okay. Oh, I maybe switched. No, it's n. Yeah, it's good. Okay, so the first column. So here we have 1, 2. Okay, now the first column. We basically need to catch only the 4, right? So we would go from I would be range of 1 to 2 minus 1. Yeah, just remove the -1 here. And minus layer. So what would it be? It would be 2 minus 0, so it would be 2 also. So just looping from 1, so it would be grid of 1 minus 1, 0. Oh, maybe not the -1 here also. Okay. Much more problem of -1. Yeah, here we would take like the 1 element. The n minus 1 is also n minus 0 is also 1. So yeah, this one is good. Okay, then let's just for the 3 here. What do we need to do? We need to go. What I is actually doing is actually from the range of n minus 2. Okay, 2 minus 2 is 0 minus layer. That's not a good thing here.
Here, since we only have a little bit left, let's just feel free to run the code as much times as you like. Let's just focus on getting it working.
Okay. So where's the okay? We have an index error here. On 1, 2, 3, 4. Okay. Maybe let's print some I here to debug a bit. Okay, I is 1. Okay. N minus 0. Oh yeah, -1 here. That would be good. Let's just verify the answer at this point. 1 to 4. Okay, right? After this one, I didn't debug it, but is this good? I have 0. Okay. I don't gather anything from this loop. Is this good? I mean, yeah, I could just take it here, but I need to make a choice here. Okay. Let's just assume I take it at the second one. Do I take it right now? No. Okay. Let's just run the range here to see if my indexes are correct. 0, 0, -1. Okay. So I need to catch the 3. Yeah, I will take it first at the first loop here. I think it's better. So I need to n minus 2 would be 0 minus layer. Yeah, that would be a problem, right? I need to go, which is n minus 1. 1 to 0 -1. Oh yeah, it's because it's +1. Okay, let me print my coordinates here to see where I mess up. Okay, I don't run the. Okay, maybe it's a -1 because I'm not going all the way through. Yeah. Okay. Yeah, I think it work here, but if I take another matrix, I don't think it would work.
Let's try with this one.
I think I have some 1, 2, 3, 4, 5, 6, 7, 9. Oh yeah, just by
Oh shit.
this one. What's the matter? Oh, it's like okay. Yeah, that's it. That's my print.
Index out of bounds.
Okay, that's my -1 here. Yeah, the -2 here and the -1 here is a bit confusing. One, 2, 3. I have my prints. Oh yeah, I have my prints here. I have to remove it.
It's missing.
It's missing the 4, right?
Yeah, 1, 2, 3, 6, 9, 8, 7. It didn't get the 4.
Yeah, that's my last loop, I would say. I didn't debug it. Isn't that why I take +1 here? No, just layer. Oh, what's that? What's that output? 1, 2, 3, 6, 9, 8, 7, 4, 5. Yeah, okay. It's a bit messy, but I think it will maybe some triangular one,
Yeah,
rectangular one. Sorry. What's the output? I need 1. Oh, okay, that's clear. 46 here. Oh, okay, this might be, I think it's on the second layer. That's, no, this on the first layer. All right. Where are my calculation wrong? I'm 46 here, so we need to take the 8 and the 12. Do I have my 1, 2, 3, 4? Yeah, I have those. So I'm basically starting from 1 until n minus layer. And n minus layer. Isn't that -1? Because, yeah, that would give me an index error here. But is it like I or layer? I need to catch where is the index error, right? No, it's like this. Okay. One, 2. Okay, that's my I. That's it's missing. And minus layer. Yeah, isn't that -1 here? Okay. I have a result 1, 2, 3. Is that? Oh yeah, it's here.
Let's make
1, 2,
sure
3,
all
4.
of the different ones work now.
Indeed, it's missing the 11 here. Where's the 11? It's here. Okay, why? I start n minus 2. Okay, just to I have too much prints. Let me remove them. Okay, does it work? Okay. Let me check. 1, 2, 3, 4. Yeah, 6. Yeah, there's some bugs here. Which is 1, 2, 3, 4. Yeah, 8, 12. Okay, 11. Okay, 5, 6, 7, and 6 again. Okay. Why 6 again here? Isn't that my n minus 1 here? I think the -2 was a mistake. No, that doesn't change anything. Okay. I don't like just debugging the code without really knowing what I'm doing. n -2 minus layer.
Yeah.
-1. No, just
Okay. I think we're at time now,
yeah.
but I think you made some good progress. How do you think you did? What's your analysis on yourself?
Yeah, I think pretty good on the first one, but on the second one, I've already done this one, but like a long time ago. Didn't really really recall it recently. But yeah, I would say pretty messy in the indexes in the second one, but the overall idea was good. The 2 divided by 2 equals 0 is a bit a bit funny, but yeah, I think the question I asked were relevant, but like yeah, the indexes were a bit messy here. I
Yeah.
maybe need to draw more and to really understand what I'm doing with my indexes.
Yeah. Like an easier way to do this one is sort of just maintaining like a top. This last question is like maintain a top pointer, which would be like 0, right pointer, which is equal to like calls -1,
Hmm.
bottom equal rows -1, and then left equals 0, and sort of like print out the top and then like add 1 to it, then like print out the right and then like reduce it by 1, and
Okay,
print out
yeah.
the bottom, and then just know what you're doing, and then print out the left, and then print out the top again, but since it's gonna be like 1 down, so it's kind of like
Okay,
having
yeah,
like 4 pointers. You know what I
yeah,
mean?
yeah.
Yeah, that would be like a easier way to do it, and all your conditions here would just be like which direction am I printing? Is it the top, the right, the bottom, and the left? And if it's like the top, then I just need to go from left to right, and
Yeah,
these
okay.
will be adjusted, something like that. Like yeah, I would say for this one, I think thinking about it layer by layer, it was good. Like you're able to get it. I think it's could be. I've seen people solve it that way, but sometimes it's overly complicated, and I think
Yeah.
you got to that case because it was hard to debug. Honestly, at some point, I couldn't even know what was going on. That's why I was like, just run it as much times as you want and get it working. But you're making good progress. I think if I give you 10 minutes, 20 minutes, maybe you'd be able to solve it. But you just had to play with the conditions a bunch. Um,
Yeah.
yeah,
Maybe
honestly,
I
you
could
had
also
you.
like
Oh,
to
go ahead.
yeah, to just like maybe like we do in graph problems like with direction here and just looping to the direction
Yeah.
maybe in like a specific order in the spider order maybe it would be much easier. Okay.
And yeah, I think overall though you had good debugging skills. You're able to find the index out of bounds and adjust the ranges to make sure that you were not getting index out of bounds anymore. So you're able to read the input or read
Hmm.
the error and actually find where the error was happening by reading the line that it was throwing on, and then figuring out, okay, it's the way I'm printing the row or the way that I'm printing the second column. So overall, I think you did pretty good. You solved the first question pretty easy as well. I think you did well with clarifying the right questions. Things like for the second one, you're asking like, is it going to be a square, a rectangle, etc. You discuss one or you discussed an approach and was able to like implement the approach you discussed, and then you were dry running it pretty well. But yeah, it was just not, you just didn't weren't able to fully complete it. But I give you I would still probably lean towards like passing you on the interview just because you pretty much got most of it. But yeah, it's kind of a weird question. I don't know if I would ask that question again, but I think overall you did pretty good. I would
Yeah,
just
okay.
address the feedback that I mentioned.
Yeah, it's a bit of a math question. Those are not my favorites.
Yeah, but overall, honestly, your coding is really good. Your understanding, like you definitely are super comfortable with the language. You pumped out a lot of code. You like there's nothing wrong with coding. It's like I can tell that you know how to get the code done, and you're not really thinking about the code and getting the code to work. You're more just thinking about the algorithm, getting the algorithm to work, and I think that's a good place to be, because some other people I've interviewed before, they kind of have a solution in their head, but then also when they're writing the code, they're tripping up on writing the code. And they're thinking of two things, getting the thing to work and also writing the code. But I could see that, yeah, the code is kind of like second nature at this point. Or first nature,
Great.
whatever. Like, you don't really have to think about it. You just have to think about the algorithm, which is good. So I think overall, just
Yep.
keep practicing questions. You'll probably pass a lot of interviews at this point. Maybe at a different time, maybe next time I send out the links, we can do one again. And then I'll ask you even harder questions because I kind of want to see like how good you are.
Yeah. Happy.
Cool.
Happy to do
All
it
right.
again.
Good luck
Yeah,
with your
thanks a lot,
internship.
James.
And talk to you a different time. See ya. Bye.
Yeah, see you, James.
All right. Okay, 2 candidates down. I need a quick break again. Who's the next person again? You seen him? How do you know him? So, yo, chat. I'll be back in 5 minutes. Literally, wait. This is a long. This is a long. This is a long stream. That's why I have to take lots of break. What the heck? What the? Oh my god. Give me a sec. Give me a sec. 5 minute. 5 minute. Mars, no problem. Anytime. Let's do this again. We'll do another one soon. Alright, we got our next candidate. What's up, man?
Yo, what's good? Can you hear me?
Yeah. How you doing?
I'm good. How are you doing?
Pretty good. Have we ran one before or no? Your
Nah,
first
that's
time?
my first one.
Cool.
Yeah.
Alright, just finishing up. How long have you been watching the channel?
Oh, dude, it must have been like a couple months now.
Yeah, I feel
Yeah.
like I've seen you for sure. You've been on all the streams for sure.
Yeah, I
you
catch
just-
most of them. I feel like.
But then it's your first time. That's crazy. Have you been prepping then?
Yeah, yeah, I'm actually not in school anymore. I've been working for like 2 years now, but
Oh,
I've been
nice.
getting back to lead coding. Yeah.
Nice. You were working are you working at like a startup, Fang, or big tech, or?
Um, it's like a mid-sized company, I'll say. Yeah.
Where are you working? East Coast, West Coast?
I'm in Florida.
Oh, nice.
Yeah. Pretty good weather here.
Yeah. Did you choose to live there? You're like, oh, I want to live the weather's way better.
Oh no, they just kind of moved me here. I mean,
Okay.
yeah, not too much complaint.
You
So
working for
much
like
complaint.
a finance, like a quant or something?
No, it's like they nah, it's like they do like software for the government pretty much.
I see.
Yeah,
Cool.
yeah.
All right, I'm gonna start this up.
All right.
Hey everyone, so today I have someone from NYU. So he graduated 2 years ago. And yeah, do you want to give a quick introduction on yourself and then also a little bit about how many lead code questions you did?
Yeah, so I graduated from NYU like a few years ago. Been
Mhm.
working for 2 years. I've been recently getting back to lead code. Yeah, trying to get into like a Fang adjacent company.
Yeah,
So yeah, that's like my goal. I've done around like, I mean, in total probably like 200-ish,
I
but
see.
it's kind of like a off and on process. Yeah, but I've been more consistent lately for sure.
Yeah.
Yeah.
How has the job hunt been for you since I mean, you went to a really good school, you already have some work experience. Is it still rough or no? Like getting interviews,
Yeah, I think it's still pretty rough. Yeah.
like you're not getting any calls at all, even from like
Um,
non-fan companies, startups and stuff?
I feel like no, there's definitely some like recruiter like emails or calls, but like they don't land much into like the later
Hmm.
stages of like interviews. Yeah.
Okay. So what's kind of your strategy for getting into Fang?
Oh, yeah, just gonna grind my lead code, grind my. So I also want to get into like studying for system design. I haven't started on that yet, so
Okay.
that is definitely on my list. But for now, I'm trying to get really comfortable with lead code
Nice.
first. Yeah.
So get comfortable. Get ready. I mean, but like, how are you gonna land the interview? What's your plan there?
Oh yeah. Yeah, I think I have to like do more impactful personal projects, not gonna lie. So like my resume, it could be better. Like I at first I thought like some job experience would be easier, but doesn't seem like the case. Yeah, so I'm gonna do more like impactful projects, and like just like clean up my resume in general. Yeah.
Yeah. I mean, honestly, you're at the 2 year mark, and 2 year mark is good, but it's in a weird state where
Yeah.
you're just almost past being a new grad for some companies, because usually in most companies they're looking to hire intermediates, and usually they have like 3 to 4 years of experience. So
Yeah.
and then usually for senior you need 5+ experience to get hired. So I think you're almost at that phase. Because I remember I started applying when I had only 2 years experience. I wasn't getting that many interviews. But once I hit 3, I started getting a lot of interviews for intermediate positions. So it's kind of like you'll still get some, but it's a little early. But yeah, so let me think. You've done 300 questions. How comfortable are you with LeetCode? Can I ask you hard questions, easy questions?
Um,
Just
yeah, I don't
avoid
think I'd be
DP
able
or
to do
whatever.
hard.
Okay.
Yeah, so actually no DP yet. Yeah, I haven't studied too much DP, but everything else I think should be fine. Yeah.
Were you the one who recommended do cousins too or something like that?
No.
You ever done that question? Okay.
Yeah.
Okay. What
We doing
programming
that one?
language? Yeah, what programming language do you
Okay.
want to code in?
Python. Yeah.
All right. Let me see. Let me give you a nice question to start it off with.
All right.
Let me see.
Low-key getting kind of nervous here. Just like a real interview.
Let me give you a good. All right. Let's go with this one.
All right.
So, we're pretty much given the root of a binary tree. We need to replace the value of each node in the tree with the sum of all of its cousin values. 2 nodes of a binary tree are cousins if they have the same depth with different parents. So return the root of the modified binary tree.
Okay. Let me read it again. Okay, I see.
Yeah, and we could work through some examples. Like, I'll let you go and drive that aspect, like clarifying.
Replace the tree. Yeah, so are we always given like a non-empty tree, or yeah, can we assume that?
Yeah, but we're always given 1 node.
Okay, I see. Yeah, let me try to write up a quick example. So for this tree here, so these 2 nodes would not be cousin because they have the same parents, right, on
Yep.
this level. But on level 3, let's see. So nodes 4, 5 are cousin to 6, 7 because they have different parents, but they're siblings
Yeah.
of each other.
So
Okay.
4's cousin is 6 and 7. 5's cousin is 6
Okay.
and 7. 6 cousin is 4 and 5. 7 cousin, yeah.
Yeah. Okay. Sorry. So we're gonna want to replace 4 with so we're gonna want to replace 4 and 5 with 13. So that's 6 plus 7. And then we're gonna want to replace 6 and 7 with 9, right? 13. So I think this is gonna be the modified tree that we get. Yeah. Okay. So.
Oh wait, don't modify the input for now.
Oh, okay, yeah, sorry.
So we can verify.
Oh yeah, we kind of lost some reference there. 4, 5. Yeah, 6, 7. Just gonna start a new line here. Yeah, so 4 and 5, the new value is gonna be 13, and then 6 and 7, the new value is gonna be 9. Because these 2 nodes are the cousin of these nodes, and we just wanna replace the values of the nodes or the cousins. Okay. Yeah. So I think, yeah, first thing come to mind is we have to run some kind of BFS, because just like a naturally good way to calculate values like level by level.
Wait, what would the output be here? 1, 2.
Oh yeah, it's gonna be like 1, 2, 3, and then 13, 13, and then 9, 9. Yeah. Yeah. Does that look good to you?
Yeah.
Okay, yeah. Yeah, so I think we want to run some kind of BFS. And we also want to keep track of the parent when we are processing the nodes. So we know like which cousins in the same, which node in the level are like cousin or siblings to each other, so we can calculate it properly later on. Yeah, let's see. So yeah, so going back to the original example, so in here we begin a BFS process, we pass in 1, and then we will queue in 2 and 3. So 2 and 3, we see that they have the same parent of 1, so we don't modify their value, and we begin killing their neighbor again. So we get to 4 and 5. Yeah, so these two nodes. So here we'll see that 4, 5, 6, 7. Okay, I see. Okay, so once we are at a level, we will want to keep track of all the nodes with the same parent, and then we want to sum up the values of the nodes that have other parents, if that makes sense. And then we, yeah, replace it later on.
Okay.
Yeah. So, yeah, 1, 2. Yeah, like we wouldn't want to like replace it immediately because we're gonna lose like the original value. So I think we're gonna do the calculations and then we're gonna replace every node in the level at last.
Pretend we had something like this: 1, 1, 1, 1, 1, 1, 1.
Mm.
Space this out a little bit.
Yeah.
Like basically, what I'm saying is, how am I gonna add up efficiently all of the cousin values? Like if I'm looking at this one, or pretend I'm looking at this one.
Right.
If I'm looking at this one right here, how I'm gonna add up all the ones beneath it, or all the cousins efficiently? Because even if, because it could just be like a, I mean, we could do like for each one a double for loop or something. Like for this one, look at all these ones. Then for this one, look at all of them again, except for the cousins. Is that what you're thinking?
No, I was kind of thinking like, so when we are at this level, like we kind of keep track of all the parents, and then we sum them up, and then we see that, and then for each of the node, we just calculate like the sum of all the other nodes that don't have the same parents.
But how do we do that part? That part that you're talking about?
Yeah. Yeah, yeah, I feel like we should do some pre-processing maybe. If we run like a BFS one time and then we capture the sum first and then we run it again.
So do a BFS and capture the sum of what?
Yeah, so it's gonna be like you can run a BFS and then so for the starting from the second level, we see that the sum is gonna be 5, and then we run it again, and then it's gonna be 9. So like the sum here just kind of represents
The sum
like
here.
the sum of like we're gonna have 9 and then 13. We have 5. So in here we will have like 2 and then 2. And 2.
So we're adding up each sibling.
Yeah, yeah, I guess I guess we just want to calculate the total sum of each level and then so like at one run we'll calculate the total sum of each level and then we just subtract that total sum from like its sibling sum.
Mm-hmm.
Yeah, so that should give you like the cousins for each node. Yeah, so going back, so we're gonna use that approach. So the total sum of here is gonna be 5, and then but
What about the next row?
yeah, so next row is gonna be 4. So 9 plus 13 is gonna be 22. So it's gonna be 22, and this one I believe is 8. And then in here we can just for these two nodes we can we would also want to keep track of like a sibling sums. So in here will be 9, and then we do like 22 minus 9, and then we're gonna get 13 for these two.
Okay.
And then we're gonna do 22 minus 13, and then we get like 9 for these two.
Okay.
Yeah. Does that make sense?
Yeah, that makes sense. So
Yeah.
you're gonna perform a BFS at first to capture the total sum at each level, and what are you gonna do to update the tree? Like what algorithm?
Yeah, so I think so once I do a BFS, let's see, what's like I was just gonna go with another BFS.
Okay.
Yeah, since we're just kind of doing it level by level.
Okay. I think what you said makes sense. Go ahead and implement that.
Okay, yeah. Should I write up the tree node class or?
Yeah.
Okay. And after that, I'm gonna write a function. Let's call it replace node cousin. And then we're gonna take in the root of the tree. All right. So should okay. All right. Yeah. So BFS. So we're gonna need a queue. Queue root. And YOQ. So first we're gonna, yeah, so we're gonna offer the root node to the queue. And then we can opt from the queue. And some. Yeah, actually, I think I would want to make kind of like a some array to hold the values of each level. So we're gonna pop all the nodes from each level, and then add them to the current sum of that level, and
Sure.
then yeah, if we have a left children, we can offer it to the queue. Yeah, so like each for loops is gonna signify like one level. So at the end, we can append the sum of that level. Yeah.
Makes sense.
Yeah, so doing this, we should have the sum array so sum array give us total sum of each level. Okay, so now I think we will want to do the actual replacing. Yeah, so I think it's gonna be another BFS. So I think in here we would need to keep track of an extra variable called like parent. Yeah. So we know which sum we shouldn't count towards our like the cousin sums. Yeah,
Okay.
if that makes sense. Yeah.
Yeah, it makes sense.
Yeah. So it's kind of the same implementation here. Slightly different. Oh, actually, I think we want to pass in another value. So it's gonna hold like the sum of itself and like all its sibling. So I think that'll be easier for us to calculate it.
So,
Yeah, so like if we go back to this tree, so when we are processing 4 and 5, we're gonna do like 9. Yeah, we're gonna do like sorry.
so right here we're looping through the node and we have the parent.
Yeah.
Once we have the node and the parent, we just need to, like, we already have the sum, right, of
Yeah.
of that level. We just need to do that operation you mentioned, which is sum minus, or sum of that level minus me minus my sibling.
Yeah. Yeah, so we would have to keep track of a sum that's like this of nodes that have the same parents, and we know that it's gonna, since we're doing like a BFS, it's gonna go from like left to right. So maybe we can do like sibling sum, and then so if the nodes that we are currently looking at have the same parent as the last node, then we can add to the sum.
Okay, I want to get to the second question, so we'll just stop this one here. Let me print in the next question.
Oh, okay.
Yeah, because I want to work to 2 questions. Let's see.
Yeah.
So around, let's see. So, cool. So this is the next question. We're pretty much given an array of n objects, colored red, white, or blue. We need to sort them in place so that the objects of the same, let's say n numbers, or n object, whatever, n objects colored red, white, or blue. Sort them in place so that the objects of the same color are adjacent, with the colors in the order of red, white, and blue. So essentially, I'll show you the examples. Right here. We pretty much just need to sort the array in place. So have the zeros, all the zeros in the left, the ones in the middle, and then the 2s all the way on the right.
Mm-hmm. Yeah, we must. Okay, so do in place. So we can make like a new, like kind of like a result array and then just count everything, right? Like
Making a
in
result
place.
array.
Yeah, it's just like a pretty easy solution that comes to mind. It's just
Yeah.
like count how many 0 and 1s we have and then just append it to like
What
a
would be
new
the time and
array.
space complexity on that?
Yeah, it's gonna have like a linear space and time because we have to make an array to hold all the result and we have to loop through the array twice.
Okay,
Yeah,
what about
but-
space?
It's also gonna be linear because we have to allocate memory for like a new result array.
Okay, what about can we get it down to O1 space? Because yeah, creating a new
Yeah,
array would be easy.
yeah. So if we want all of one, then we have to do it in place. Okay. So I think since there are only like three possible digits, 0, 1, and 2, we can probably use like 3 pointers to keep track of like where the 0 or the 1 or 2 should go. Because 0, they have to go to like the beginning of the array, and then the 1 will have to go to the middle, and then the 2 will have to go to the end. So I think with some pointers, we can do it in place. Okay. Yeah, so I think we would want some kind of 0 pointer. So in here, gonna have like a 0 pointer, and then we're gonna have like a 2 pointer. So at each iteration of like our loop, we're gonna want to move 0 to where the 0 pointer is pointing to, and then move 2 to where the 2 pointers are pointing to. I don't think we would need another pointer for 1, because the 1 would just go in between the 0 2s. Yeah, so that's like the general idea that comes to mind. Yeah, so let me try to run that approach on this input over here. And we also gonna have like a current pointer. Yeah, so we see that this digit 2 should go to the end of it. So we swap that. So we have, so first iteration, we swap the 2 towards the end. So we're gonna have to move the 2 pointers. And then going back to it, we see that the digit that we have swapped over is a 0. And that is what we want at the 0
Sure.
pointer. So we can also move the 0 pointer. And then we can also move the current pointer. And then we see that it's a 0. That is what we want since it matches up with the 0 pointers. We can move it again. Let me kind of space them out. Yeah, okay, so here we see another mismatch. We will have to swap them over.
Yep.
With where 2 pointer is pointing to. Yeah. And then we swap a 1 over.
Oh wait, go back.
Oh,
Like, Command Z. But that's a 2, right? What do we do? Or how did the 2 pointer go down?
oh,
The 2 pointer was here before, right? I thought. How'd you
oh
do-
no, I just kind of spaced them out. It was supposed to be like n-1, like n-2.
So it's not
'Cause, like,
starting
the-
at the 2, it's starting at the 1.
No, because previously I already swapped a 2 towards the end, so I already have moved the 2 pointers.
Okay.
Yeah, I just
I
kind
see,
of
I
like
see.
messed it
Okay.
up the spacing
Okay.
because I spaced them
I
out.
see.
Yeah.
Makes sense. Oh, I see.
Yeah.
Yeah.
Yeah. Yeah, so we see a 2 again. So we want to swap it to where the 2 pointer is. So we swap. And then we move the 2 pointers.
Okay. I think overall it looks promising. Go ahead and implement it.
Yeah. Oh, I was just gonna say, so I think we would want to end the loop when our current pointer like overlap the 2 pointers. So that means like everything should be sorted. Yeah. Sort colors, let's call it. So we don't, okay. So the input is just gonna be like a num array, right? Num array. Do we need to return anything if we're gonna do it in place? I guess we can just return.
Return me
nums.
the num so I could verify.
Yeah. Sounds good. Yeah, so if we see if nums, so if we see a 0, then we wouldn't, I don't think we would do anything if we see a 0 because that should be in the right place. If we see a 2, we would have to swap where a current number and the 2 is. Oh, sorry. If we see a 0, we can still do the swap because we have to increment the 0 pointer and keep track of it. So we're gonna increment, there should be a minus. Yeah. Actually, I think a while loop would be better because I want the condition to be while I doesn't overlap the 0 pointer, the 2 pointer, sorry.
So I incrementing the pointer. If it's 0, swap.
Yeah. Oh shit. Yeah, if it's 0, we will want to swap with the current number with where our 0 should be. Yeah, so the same logic applies to yeah, let's see. Yeah, let me try to dry run the code on some test cases. I guess you ran it here. Can I just since you ran already, can I just kind of
Yeah.
put in some other cases here? Okay.
Yeah, put in some cases.
Yeah. Okay, so this one is not right. I'm gonna try to make it smaller so it's easier to debug under Synchrony.
I'll give you this case right here.
Yeah. One zero two. So first we're gonna look at these numbers. So we're gonna swap a
Yo,
1.
chat, CJ, like Coding Jesus did a
2.
review on his code and it was
And then
bad. Really bad. I was looking at it too, I was like,
we're gonna
that's terrible code.
oh sorry. We're gonna swap the 1 with the 2. So we would decrement the 2 pointers. Oh, I see. Okay. So in with my current code, because I'm gonna increment the I, so the I is gonna be incremented to the 0, and then wow, I is less than yeah, because it's the condition would break, so it wouldn't run. maybe I just add an equal sign.
So it hits the 1 and it just skips the 1.
Yeah.
What'd you change?
Yeah, I think. Oh, so I added like an equal sign here. Yeah. But I wonder if that's like that'll only work with like this specific test case.
Yeah, I think it might break on larger test case.
Yeah. I feel like I'm not correcting the 1 properly. Um,
Because what happens when you get to the 1? What happens?
mhm.
Or sorry, what happens
Like-
when you get to the 0? Okay, you get to the 1, that's fine, you skip. When you get to 0, or just do a dry run on this small test case. That one worked, but pretend we have. Let me draft one up, or okay. I'll do another one right here. One, two,
Two
zero.
bricks on this one. Yeah, let's see what's happening on this one. Yeah, so we see a 1, so we don't do anything. And then and then we move to the 2. So we see a 2, we swap it with the 2. Yeah. Oh, okay. So I guess when we swap, there's like a possibility we swap in like a 0, and then we shouldn't always increment an I pointer. We should recheck what our current index is pointing to. So in case it's a 0, we should move it to the correct position. Yeah, so this is 0. So when we swap it, wonder does it just cancel? Yeah.
Okay. We only have a couple minutes left, so want to end it here. How do you think you did on the interview?
Oh,
This one's close already, so yeah, we'll just stop it here.
Yeah. Yeah, I mean, I would have wanted to be better, but yeah, kind of still getting my groove in. Yeah.
Yeah, let's see. Yeah, I mean, you solved 90% of the question there, but it's just the case, yeah. Like when you, for this one, when when we have the 1 and 0, 1, 0, and 2, when you swap, you go to 1, or no, it's 1, 2, 0. Right. Or what was the one that broke? Was it 1, 0, 2? Oh no, that
I
one.
think it's 1, 2, 0. 1, 2, 0. Yeah. Oh wait. Oh, maybe because it's my new code. Oh wait, let me get rid of. Yeah.
I minus 1.
Yeah.
Yeah, 1, 0, 2. Let's see how that works. Okay, you have the 1. You move on. So pretty much what happened, right, is you flip the 2 and the 0. So you get the 0 and the 2. And then you would increment. But 0 is not in the right place. So you kind of have to stay on that same one and then flip the 0 with the 1. And only then you would move over. So it's just like you need to change up this condition just a little bit. I think maybe an if statement here. Something like that. But
Yeah. Yeah, I wonder if this will just work, like if I like kind of decrement if I swap a 2 or something.
I mean, let's try
So like
it
it
on
would
this
stay
first
on
one.
like the correct position.
For 2. Okay, what it feels like. Yeah. So what does a decrement actually do? Why does it just stay for 2 and not for 0 or something?
Yeah, because I think so when we see a 0, like if what a eye pointer is pointing past, like I think 0 must be in the right places. Because like if it wasn't in the right places, like let's say like if it's like a 2, then we would have swap it towards the end. And then if it's a 0, we would swap it to where the 0 should be. If it's a 1, we don't do anything.
Okay.
Yeah.
I think overall, like, yeah, it's really close. Yeah, I think what you'd have there might work. I'd have to test it on LeetCode. Let me just quickly test it. Actually, it's right beside me.
Okay, yeah.
Oh, nice. Yeah, that worked. Cool. Yeah, you're able to get the question 2. I think for question 1, you clarified it well. You're able to figure out a solution, but it took some time for you to think. And you came up with a good solution, which is just take the sum of, calculate the sum of every row using one BFS, and then doing a second pass where you subtract the total sum of that row minus itself and its sibling. But I think you're just having trouble with that second second BFS and just tripping out on the logic there. So you weren't able to actually get it done. So I think just needs more practice to just make sure that you can implement that fast. And it's a slightly different variation of BFS than what you're used to,
Yeah.
which is why it probably tripped you out. So yeah, I would work through that problem, work through variants of BFS to just make sure you iron that out. But I think overall, I mean, the way that you walk through the solution, and I think you're able to dry run the code really well, and then you're able to explain me exactly what you're thinking. So I can, and that's helpful for me because I'm able to find out where you're stuck and give you pointers. But some of the problem solving could just happen a lot faster, and that all just comes from practice. I don't think you have any issues with like the language or working with pointers and everything. You showed you're able to do that, but just getting to the solution faster and implementing it faster with no bugs.
Yeah, for sure.
Cool. All right. Thanks for taking the time out.
All right, thanks, man.
All right. See ya.
Peace.
Peace. So next we have somebody with 100 LeetCode. 100 LeetCode questions solved. Let's see. Oh no. It's a higher on the second question for sure. No higher on the first question. This one. Actually, anytime when you're doing interviews, anytime you're leaning to maybe hiring, they tell you just do no hire. So if this one was a maybe hire, I'm gonna say no hire. And the reason I'm tracking these stats is I'm just trying to see like how many questions people are able to solve and see like the percentages there. Okay. Cool. Taking a quick 5-minute break. Mars, don't worry. You're able to solve it after. That's all that. It's better to not pass now than to not pass when you get your real interview. You're a maybe higher on that question. So it's really close. But strong, don't worry, you got a strong higher in that first one. So I haven't had somebody yet solve both questions with a strong higher. So it's going to be interesting. The next person has 100 LeetCode. I haven't conducted meta interviews yet because I just started. Okay, I'll be right back. 5 mins. God. Give me a sec. Everyone, stay on. Don't dip. Next person is gonna be good. And definitely be here for the Code Forces guy. This guy is super impressive. We back. Fix up my audio. Got the next candidate on. Interesting. If the next candidate doesn't come on by the time, I'm gonna somebody sent me an Adobe coding interview and I'm gonna go through it. If this next person doesn't join, we're gonna work through this. We're gonna do this hacker rank. I'll give them like 2 more minutes, 5 more minutes. Which question? I've done that question before already. You want me to explain it? Or what? Serialize and deserialize the n-ary tree. Have I done this? Oh, I haven't done that. Yo, I have I'm gonna do a video on the 10 computer science courses you must take. What the heck? Did I delete it? No way. What happened? Interesting. Mr. B, you want me to explain this problem right here? Yeah, for sure. Wait, let me just check my audio. Sorry, give me 2 seconds. How's my audio sound? Input. Chat, who here knows how to solve this question? Serialize and deserialize a binary tree. Who here has solved this question? Mr. B, have you solved it? Or no? Yeah. Okay, let me read it. It's been a while. When's the last time I did it? So it's been 7 months, so I don't 100% recall the solution. But let's work through this question. So we need to serialize a binary tree, which is the process of converting a data structure or object into a sequence of bits so that it can be stored in a file or memory buffer or transmitted across a network connection to be reconstructed later in the same or another computer environment. We need to design an algorithm to serialize or deserialize a binary tree. There is no restriction on how your serialization or deserialization algorithm will work. You just need to ensure that the binary tree can be serialized to a string, and this string can be deserialized. Okay. So what does it mean? Why do we need to serialize and deserialize this binary tree? Pretend we need to send this binary tree like via an API call, and then maybe the backend is gonna operate on this binary tree. We can't just make a post request with the binary tree. Pretend we had the tree node of the root, right? Pretend we had tree node equals root, and this was a binary tree. This was the root of a binary tree, and then under that tree is like a full out binary tree. But it's of type tree node. Imagine we had to make like a post request to a server, like a DFS endpoint, and in the body we had to pass in like a root, and then we just passed in this root. You can't just send a Python class or a Python object via an API call. You need to put it into something like a string, because the language that's consuming it might not even be in Python. It could be in Java, it could be in Go, it could be in something else. So we need to put it in some format that when we send it to the backend or wherever that needs to deserialize it, like it has like a basic format. So it wants us to encode it in a string, so when it sends it over, we can later deserialize it in whatever object you need. So how's this gonna work? We have 1, 2, 3, 4, 5. So basically we need to turn it into a string, and then here we need to decode it and turn it back to a tree. So we just need to put it into some format where we can deserialize it. So let me think. Well, if we're given the root, I've already done this question before, so I have a sense that we probably need to traverse the tree in some way and store it in either the pre-order, in-order, or post-order traversal. And then we just need to perform that, and then when we deserialize it, we just need to perform that same traversal in order to reconstruct. So pretend we did a pre-order traversal on 1, 2, 3, 4. 1. Let's go like this. Pre-order traversal means we're gonna do 1 first. We're gonna do 1. Pre-order is 1. Then left. So we're gonna do 2. Left. And then we're gonna do 3. Then 4 and 5. But what we need to do is we just need to keep track. We go 1 and then we go 2. Since 2's left child is null, there's nothing, because if we just printed the pre-order traversal, we got 1, 2, 3, 1, 2, 3, 4, and 5. This doesn't tell us anything about the structure of the tree. It could be 1, 2, 3, 4, or like 1, 2, 3, and then 4, 5, like that way. Or it could be pretty much 1, 2, 3, 4, 5 doesn't give us the structure of the tree. So we need to figure out, we need to also store the null values. We also need to store the null, or we need to keep track of where the null values are, so we get the full picture of the tree. So if we do 1, 2, when we go left, it's a null, so we could just store that in like a hashtag or whatever. When we go right here, we store that a hashtag as well. Then finally we go back up. Then we go to 3. Then 3 we go its left child. We go 4. 4 has left is nothing. Its right is nothing. So we go 3, 4. And finally we go up, and then we have 5. And then 5 left child is nothing. Right child is nothing. So now this tells us a lot more. It tells us where the null values are if we do a pre-order traversal. And yeah, and then I think pretty much what we need to do is when we just turn this into a string, and that's how we serialize it. When we deserialize it, we just have to do a in-order traversal or the pre-order traversal again. So what we'll do is like we'll turn 1 here. We'll turn this into the root node. So this will turn into 1. And then we pass here. This will turn into 2. This. And then we do a left child. Once we get the left child here, if it's a null, we don't set the left child. Or if it's null, yeah, we just set the left equals to none. If it's null, because like, okay, I'll also have another pointer at where we are in the tree. Once we have a right here, we'll just put that as null because it's a hashtag. Now since we set the left and right, we need to recurse back up. And now for here, we're setting the right. The right is, so we just need one pointer going along the string here. We just need one pointer going along the string here, and then we'll just be performing the pre-order traversal. But this will be at like the global level here. So, and we could just do a pre-order traversal again. So it's gonna look like this. So we'll just do a pre-order traversal. What's a pre-order traversal? It's like left, right, or it's visit node, then go left, then go right. So what we're gonna do is we're gonna serialize we're gonna perform a pre-order traversal here. So we're gonna be like, let's do def pre-order self node result. So we'll just put a result here. This is the encoded string, and then eventually we'll return that result. But we're gonna do pre-order serialize. Pre-order serialize. We'll do pre-order serialize. We'll pass in the root. We'll do some checks first. If root is none, return empty string. Yeah, you're right. Result. So root and then result. We don't really need default here. So what we're gonna do is to do the pre-order. What we're gonna do is if node is none, we do result dot append a hashtag. And then we return, and then we do a pre-order. So that means we do result dot append node dot value, and then we go left and right. Result or dot left, or no, we just need to do self dot pre-order here, node dot left, node dot right, and return. I mean, there's an implicit return there. So this is a pre-order because we visit the node, then we visit the left, then visit the right. So that gets us this string initially, right here. This one right here. Now we kind of just have to do the deserialization. So if the data is equal to empty string, we just return none. Or empty, wait. Yeah, we just return none. Okay, now we need to do the pre-order, but deserialize. So we'll call it like deser. So what we're gonna be given is we're gonna be given our data in an index. So the data is going to be here, and then the index is going to be with what number we are on currently, like what number we are in the string. So what we'll do is, wait, let me think about this. Yeah, we just need to return self dot pre-order deserialize on the yeah, I don't think we need a node here. We just need the data and the index. And then we'll just pass in the data, but we'll do a split. We'll take the data dot split on the commas, and here we didn't join. We're gonna take the result and we're gonna join all the elements by comma, and then we'll split it here. We'll split it here to get like the each node's value there. And then also what we're gonna do is we're just gonna pass in the index as 0. So what we're gonna say is if index is greater than equal to the length of data, or data at index is actually equal to a hashtag, that means we're going to return a null value, because that means it's actually none. Otherwise, what we're going to do is we're going to create a node, and we're going to create that node. We're going to create that node with data at index. Let's see what this is. So for example, we start at data index with 1. So we're going to create the first node with 1. I think all we need to do is return this current node, but we need to do, we need like a global index. Wait, well, because this is 0, 1, 2. Wait, let's see this. Current, something like this. Current. I'll check if we need a global index after that just keeps incrementing, but maybe all we need is current node dot left, current node dot right equals data index plus 1 index plus 2. I think we might need like a global counter that just keeps incrementing. Okay, let's look at this. We create a node 1 like that. Then we recurse on the left child here. Left child goes here. We see that the left child is actually a 2. Oh yeah, we need a global counter, because left child here is equal to 2. Like the third and fourth index, like, Yeah, because when we passed the right child, we passed in index plus 3. So that doesn't work. So we need sort of what we would do is like this is a hack right now. So done. Index equals 0. So we wouldn't pass a index here. What we do is self dot index plus equals 1. And then here self dot index plus equals 1. Okay, let's do a dry run. Is that code making sense so far, chat? See if that works. Runtime error. Oh. Oh yeah, we don't even need this anymore. We don't need this anymore. So we need a global counter so that it's always just moving forward here. Because when we're at this 1 right here, if we just pass down like index plus 1, which at the time it's 0, it's going to be pointing at here. But essentially what it needs to do is it needs to skip ahead like this. It needs to know the number of elements in this subtree and skip ahead on this graph. So that way, so we could just have a global counter there. Here, I think all I need to do is in the pre-order here, I just need to turn this into a string. And here, I just need to turn this into an int. Turn this back into an int. Invalid data return. Wait, let me give me a sec. Print. Oh, it's called tree node. Okay, that worked. Invalid data return. Pre-order. Yeah, but I'm using the global. Oh, sorry. Little bug. Invalid data return. That means I'm not passing the right value in. So, okay, let's just make sure that it's actually so we're taking data and then we're splitting it by comma if the index is greater than the data. Oh my god, you're right. This is why that's why I hate copy and pasting. Did it finally, okay, invalid data. Am I supposed to put it as a string? So how I debug this is like print result. Print result. Result.append. Okay, I printed out the tree node. What the heck happened? Okay. Let's just print out this res and just make sure that res looks good. What's the first? Okay, that obviously works. Self.preorder deser. Take self.data. And we're doing the deserialize here. Am I even getting here? There's like a weird, there's like probably some, there's probably like a small bug on the deserialization. Let's just look through it. If the data equals this, equals empty, return none. Like, what am I getting here for data? Am I even getting anything? Yo. What's going on? What? Is it even calling deserialize? This is so funny. Okay. Yo, chat, you see the issue or not? Oh, shoot. My bad. Invalid data returned. Oh no, I'm dumb. We need to join the result here. Yeah, we don't even, my bad. We just need to join the result here. So we do the pre-order, we pass in the root. That should work better. There you go, there you go, there you go. So now let's just print out, let's actually print out the data here on the first one, and it should match what we have here. Shoot. It should match what we expected, which is this. 1, 2, negative, or 3, 4. Yep, perfect. And then, okay, now all we need to do is return res right here. Holy. So I just messed up that one line in here, like I was doing the return here. Okay, y'all wanna do y'all wanna try out the other one? Let's do this. Let's see. Serialize and deserialize an n-ary tree. Bro, this one's... Deserialize and serialize an n-ary tree. Okay, this is gonna be fun. Yeah, building that tree is annoying. So we're gonna be, so it's pretty much the same thing. We might be able to just do a pre-order traversal. Take a look at this. We might. That's crazy. No way. So they start with the 1, or we start with the 1. We get 1. Then we go to left. We get 2. Then maybe we can do like hashtag. Oh no, we can't do hashtags because it's just the children. It's just the children. So we can maybe put a hashtag. That means we need to go backwards. Or 2, 1, 2, that means it's backwards. Now we have 3. 3. Then we go 6. 6 is a child. And then we could put a hashtag. So 3. 7. 11. But how do we know that it's... So now the question I'm asking, how do we know it? How do we mark child versus like sibling? Or pretty much, how do we mark 1, 2, 3, 4? Okay, pretend we do 7, 11, and 14, right? Let's just ignore this half. Let's just try to generate this n-area tree. Or let's generate this an n-area tree like this. 2, 3. Like a very simple case. We put the 1 here. Then we put the 2. How do we say the 2 has no children? Do we just go like this? And then we go back up. We go 3. Then we say 3 has no children. Then we have 4. Say 4 has no children. That makes sense maybe. Like we can do the same thing when we do 1. Then we turn this into one of the children. Then since it has no children, we recurse back up. So we build 1, we do 2. It has no children, we recurse back up. Then we have a 3. Okay. What if we had... everyone following along? I'm just playing around with it right now. What if we have 1, 2, 3? So we put 1. We put 2. Then we put 3. Then we put a hashtag. Yeah, I think they're just doing a regular pre-order. Do you think that going from recursion is enough? Yeah, that's enough. Usually you don't have to do it top down or bottom up. So 1, 2, 3. So pretend we had 1. This was encoded as 1, 2, 3. We create 1. Then we create 2. Then we create 3 as a child. Then we create nothing. What if it had a 4? And then create nothing. Then if it was a 4, if it's another number, I think, yeah. Five here, because we get 4 number. Then we'd come back, it would be nothing, and then we had 5 number. But I think we need to put another hashtag, which means like if we're okay, we need to put a hashtag that we're at the end of the level. So we can go back up. So it could be in code like this. 1, we put the 1, then we have the 2. Then we have the 3. Then we have 3 has nothing, so it goes back up. 4 has nothing, so it goes back up. 5 has nothing, so it goes back up. 2 has nothing, so it goes back up. Finally 1. Okay, so at the end of a level, you just need to mark it with another hashtag. How do I differentiate a hashtag for no child and a hashtag for no more at this level? I don't think you need to. I don't think that matters. For meta, was it 4 mediums? I don't think we need to actually like look at it matters what the hashtag is. We just need to, at the end of the level, just throw in another hashtag. So yeah, let's just go and implement that. Do I need bottom up? Not really, unless they really want you to optimize for space. Usually the bottom ups is when you need to. Nah, I've never been asked a DP question where I need to use a bottom up. So I think we can do a pre-order serialize as well, or pre-order again. So what we're gonna do is we're gonna do if the root is none, return. At the end, or so we're going to be given a node. Node is none. So what we're going to do is we're going to be given a node in the result. Here we're going to have a result again. Then we'll return the result, but we're going to join it up here. We're going to join it with commas. We're going to do producer. We're going to be given root, and we're going to be given the result. If the node is hashtag, we result return result dot append. We result dot append the hashtag result dot append. And we're saying we result dot at the end of each level we return we result dot append there, but what we'll do is result dot append the node dot value. That's the node. That's the current node dot value. And then for a child in node dot children, for child in node.children, what we're going to do is self.preorder serialize here, and we're going to pass in the child, and we're going to pass in the result. So that does we're doing a pre-order traversal on an n-ary tree. No, I never interviewed for a quant fund yet. Only like coding assessments and stuff. Result out of pen. Okay. So that deserialized, that serializes it. Let's do this. Return. Yeah, we just need to convert this to a string. 1, 2, 3. Looks good to me. Now we just need to deserialize it. So we need to do similar to this, the pre-order traversal. We're going to be given our data. If data equals empty, we're going to return none. Otherwise, we're going to do self.preorder. We're going to give in our, we're going to say data dot split on commas. Same thing from before. So we're going to be given our data. I'm going to introduce that global index for now, but we can fix that after. That's an easy thing to fix. We're going to do the same thing where you have a global index so that we can track moving from left to right on here. So if node is none. So let me just remove this code. So now we have the data split up again like this. Like we'll print the data. It should be passed into us but split. Pre-order cert takes two positional, but 3 were given. Wait. Oh yeah. So now it should print out the array twice. Perfect. Now we just need to conduct the if self.index is greater than equal to the length of data, or data self.index is equal to a hashtag. That means it's just a null. Return none. But we do self.index plus equals 1. Now in the data here, what are we gonna do? What we're going to do is we're going to create the node. It's called node. We have the Codeforces guy about to come on, so I need to finish this quick. Self.index. Turn this into an int. Then we do self.index plus equals 1. And then we're going to do the same sort of loop. Or wait, we'll create the thing and we'll do index plus equals 1. Okay, how do I build my children? Yeah, it's like it's pretty much the same. Yeah, I added an extra hashtag. I can fix that global variable. I think all we need to do is just count up the size of the subarray and return it here and then just increment that. But I can fix up the global variable after. But I don't think it will change the algorithm too much. I think the hard part is actually figuring out the children. So while self.index is less than the length of data and I think and data self dot index is not equal to hashtag, well, the index is less than and the data is not equal to. Okay, what we're gonna do is current node dot append data current node dot append. What are we gonna append to the current node? We're gonna have to recurse. I'm just doing this for fun right now. Well, like, I'm just waiting for the next guy to show up. I'm not unemployed. I have a job. Yeah, don't worry. Let me finish. Plasmatic, let me finish this quick and then I'll hop on. Oh shoot, I didn't return. So pre-order, sir. If the index is greater than equal to the length of data, or the data.index equal to a hashtag, we increment. How am I getting? Node object 1. Print for child in res dot. Okay. 1. We create the 1. We move the index to 2. Okay. We run here. Self. Okay, let's just do a simple case. 1, 2, 3. 1, 2, 3. So if I do 1, 2, 3, we go 1, 2, hashtag, hashtag. Oh, I think I need to do. Okay, wait. 1, 2. Hashtag. So mine's like 1, 2. Hashtag. Then it goes 3. Hashtag. That's the way mine current 1, 2. Hashtag. 3, and it would have put the hashtag. Plasmatic, give me a second. I'm just finishing this guy up. 3. So when we do 1, we create 1. Then we increment the pointer here. So since it's 2, we're gonna add a child, which is 2. So it goes here. It's gonna create 2. It's gonna increment index. So that's going to go here. So now we're at 3. It should add a 3 here. Then recurse. Wait, let me add a simple test case. How is this showing? Is this in a pre? One, two, three. So we do 1. We create the node. Okay, wait. Okay. Once I debug why this is only printing 2, I think this part right here is not generating the children properly. So we have 1, 2, 3, 6, 7. So we have to start with 1. So we'll do 1. We'll go for 2. We'll go 2. 2 doesn't have no children. So this is hashtag. So it should return to 3. Should return to 3. Wow, self.index. Like the thing is, I want to generate a smaller test case and check, but I don't know how they're formatting the tree here. So what do we have? 1, 2, 3. I remember there's supposed to be like a tree viewer. It doesn't even show us. Okay, 1, 2. We got the hashtag. So we go 1, and then we generate the child 2. The hashtag. Oh no, but wait. When we get a hashtag, do we just have to append 2 hashtags? Wait, it might not. We might not need to recurse on a hashtag. If 1, we create 1. We create 2. Then we go to this one. Oh, but we're adding none. What if it's equal to empty? If it's equal to empty. Shit, I can't solve this one, bro. I need some time for this one. Rough. I need to be able to craft up a small test case. I just want to craft up like a 1, 2, and 3. Like how do I add? How do I create a test case here for that? How does this work? One null. Oh, I see. I see. So if I just do 1, 2, 3. Okay, it's separated by null, null, 6, 7. Let me solve it for this simple case. Plasmatic, almost done, almost done. I think if I could solve it for this case, I'm good. Okay, where's the deser? So for the deser, 1, 2. Dude, LeetCode is so annoying. You can't actually look at the tree structure. But okay, that prints out this. We do 1 node. So we pass in the split. We start at index 0. So what we do is we take the current index and then we create the first node 1 and then we increment. Now we're at 2. While self.index is less than the length of data and data is not equal to hashtag, we increment by 2. So we'll create 2 right here. But then we'll be in 2 here. We'll create 2. And now we actually have a hashtag. So we'll go up again if self is not equal to the hashtag. But it is equal to the hashtag. Okay, I think we just need to self.index plus equals 1 here. Let's go! Holy. That one liner. That one line. Almost got folded. Just this one line. Yo, chat, try out that question. Let me get Plasmatic, are you in here? Okay. Plasmatic, give me 5 minutes. Give me a quick break, real quick. Just wait. I'll be back. 5 minutes. I need to grab something. It's already been 5 hours stream or something. Damn, that question almost folded me. I'll be right back. Give me a sec. Holy. How much do I got left? How many people have left? Four people left. This is a crazy grind. Yo, Plasmatic. Plasmatic, I'm in the Google.
Hello.
Yo, what's good? How you been?
That's all right. Pretty tired today, but
You got this, man.
you know,
Yeah.
I didn't realize it was a Google Meet. So yeah,
Yeah.
yeah.
How's what's it called? You ready to go back to school?
Honestly, I mean, hopefully when I'm like going back to school, but yeah.
It's your last year, right? Like, when's your expected graduation date?
Expected graduation is like April 2026. So that's like yeah, it's not like mentally spacing out, sorry. Yeah.
Are you gonna try to return?
I think hopefully. We'll see. Oh yeah, can we like cut like this intro part
Yeah,
out
for
of like
sure.
I don't know if you're gonna like upload a video out of
I'll
this.
tell
but
I'll
let's
tell
put
you
up-
when I'm gonna start the video.
Sounds good, yeah.
Yeah.
I think I'll probably stop talking about work stuff
Cool.
after we start. But yeah, like yeah, I think hopefully, you know, like if I can return, I mean it's still up to, you know, I'm the candidate, so yeah.
Yeah. Awesome. Yeah, I'll ask you personal stuff later. All right, I'm gonna start this up.
Yeah, like I'm happy to talk about I guess personal stuff outside of
Yeah,
video.
for sure. Cause how many people we have? 30 people on. All right,
Yeah.
3, 2, 1.
All right, let's
Oh wait,
go.
wait. Let me send you the link actually. Make sure you're on here.
Yeah, sounds
Yo,
good.
Paul,
Yeah,
what's good? Haven't seen you in a
Hmm?
minute. No, Paul just hopped in the chat. I know you all were working through a lot of the dailies together.
Let me check the.
Check the Google Meets.
Oh, I see. Wait, let me. Where is the Google Meet? Where did it go? Wait, I don't know where the Google Meet went. Hold on. Give me a second. Oh, here it is. Oops. All right, yeah. Yeah, I have like the stream, like I have the like it's like muted on like another tab that's just like closed off.
I see.
But yeah. Oh wait, next time, could I do like systems design?
Yeah,
Like,
yeah,
I
we
saw
can
you-
do system design next time. I just have to
Yeah.
prepare it for you too.
Yeah, that's all good.
Yeah.
Yeah. I mean,
Yeah.
you said you were running code this week, so I was like,
Yeah, I'll send you the link soon. I'll send you the link. I want to do a stream where I'm just doing system design for like 10 hours straight. That'd be so fun. But a lot of the people who watch my videos, they don't really or they don't really do system design yet. They mostly just want to do lead code.
That's fair, yeah.
Yeah.
I guess it's like the standard. I mean, I think it's like for me personally, like I mean, I guess I've A, never done a systems design interview, and B, like, I don't know, I'm just like never prepared for one either.
I mean, do you
so
want to
it's-
try for one right now or no?
Fuck it. I mean, up to you, I think, like if you have ideas.
Okay.
Like I think you could make the call here. I'm down to try it. Like we'll just see like
Yeah,
how
this would be funny.
if it's a dumpster fire or not. Who knows?
Okay. All right. Hey everyone, so today I have a Code Forces Grandmaster, and for some reason he wants to do a system design instead of his typical algorithmic questions. So instead of asking him like lead code hards, combinatorics, permutations, we're gonna go do something a little bit more practical. or something that resembles more of real world, what you'll be doing. For context, he's still in school. So usually system design is only done with new grad candidates and not really new grad candidates, people who have more experience. So let's see how he performs at a system design interview. So title of this video probably gonna be like Code Forces Grandmaster versus a system design interview. All right,
Yeah.
are you in the drawing?
Oh yeah, hold on. Let me. Yeah, I'm in the drawing now. Yeah. Why is it in like a separate tab? I want it to be like in the main thing, but okay, yeah, whatever. It's fine.
Okay.
Oh wait, yeah. Okay, I can leave it up. All right.
Let me think. What is the best? What should I ask you? So let's like design. Design Yelp.
Design Yelp. Honestly, what does Yelp do again?
So yeah. So I'll let you lead it. Lead the interview, and what I mean by lead is ask me questions like what does Yelp do? What are the requirements gathering part?
Okay. All right. Sounds good. I mean, yeah. My first question is like, what is Yelp? I think I've used it like maybe 2 or 3 times in my life.
Yeah. So let's say this is only gonna be an hour interview, so we're not gonna design this massive system called like Yelp. We had all these features. We're probably gonna design a small subset of it. So let's just say for now, pretend I just went to a new city. I'm visiting San Francisco, and I just want to view a list of all the restaurants near me. It's kind of like a food directory. Doesn't need to be ratings. I just need to know what restaurants are around me.
Mm-hmm.
And yeah, that's it at the most basic features. So at first, let's just start with just show me all the restaurants that are in SF, and then we could worry about finding them in a specific radius, and then storing a little bit of data with each of the restaurants. Maybe like
Okay.
the Chinese restaurant with some data like when is it open until, and a description of what the food is. It doesn't have to have a whole menu. We could like expand on that later. How does that sound?
Yeah, it sounds good. I'm just typing down on the tab.
Oh,
I don't know if
see.
yeah. Okay, let's do medium. Maybe that might be. Yeah. So we want a list of restaurants. And then like a first goal is just we want to like display a list of restaurants. I guess like in this case, like in San Francisco, like we'll just suppose like we only have data on like San Francisco restaurants, and then we'll have like geolocating as like a next goal. So just like display like radius. So like display like within like X within the radius. All right. So I'm like thinking through like what exactly. So I guess let's have like a newcomer to this. So what is sort of the end product that we're looking here as far as like the design is? Like, do you want like is it like a data flow diagram? Like, is that what you're looking for?
Yeah, well, I eventually want to have like a high level design of
Mhm.
the whole system. As in, I want to be able to talk through all the way from somebody using the app to it hitting the servers, it hitting the database, and then returning that result. So we need to be able to take or like figure out the whole flow, the whole user experience, and everything happening in the back end.
Okay. So I guess I'll start by just drawing rectangles down. I feel like this seems like a generally good approach. So I think, I mean, there's sort of like 3 main things. I think there's like a front end, a back end, and
Mm-hmm.
I think it's just H. Okay, H is handful. All right, nice. And like a front end, back end, and then like a database. I feel like this seems like the most like sort of like basic like setup. And so I sort of think like when we log onto the app, we like, so I guess I'll just start drawing this down. So this is the back end. It's like processing, and then this is like the database, which like pulls all of it. I guess like we'll just say it's like some like column-based database. Probably.
DB.
Yeah. I guess we have like medium. Maybe we can use like larger font sizes or something. Should be fine. But and we have the front end here. So I think it's like when the user like it's like basically like user opens app and then sends request for like restos. I'll say like restos. Apparently it's like a Hong Kong thing. My friend when I was in Japan he told me that.
Mm-hmm.
I had like a Hong Kong friend who was also exchanging in Japan, and she taught me that apparently resto is a user for restaurant.
Okay.
It's like cute, and you have like list of restaurants, and you just display them on a list.
Sure.
So like I think for now, since we don't really need any filtering because we're just listing all the restaurants, we can just say like that's like sort of like a simple like workflow.
Okay.
I think my main idea here is that like I want to have like a basic like design that like we can definitely like expand.
Yeah,
on,
we
like,
can
later.
expand.
Yeah, and I think of the backend. I mean, the backend just like takes requests. Probably like I guess like routes like I guess like what does it do? I mean like routes request to like the right like endpoint. And then like queries like the database for restaurants, and then like sends the list back. And then here it's probably just a column-based database. I mean, from like a restaurant like design standpoint, I mean, I guess just like we'll just have like ID, like some like primary key, name, description, category, and then open times, which like I don't really like know exactly what the format of open times like. It could be like a JSON or something, like I don't know, like just like a list of like times that's open and closed per week. I don't think it like particularly matters at this point.
Okay.
And I feel like it's like probably gonna be like reasonably flexible.
Sure.
Yeah.
Can you also write that down, or just make sure that like for each name or for each field, just tell me the data type?
Sure, yeah. So name, I guess this would be like a string. Description would be a string. Category would be. I'm honestly not sure like what the best option for category is. I feel like theoretically like this is like an enum, but it's like, I feel like string makes more sense in the context of like. I don't know. Let's go with enum for now. I'm like I don't know if like my intuition's correct on this. And then open times. I guess like ideally it'd be like a list of like pairs of like open close for like across the week. But like it's like I feel like the best way to store this is probably some sort of like blob object, because the open times could theoretically be like infinitely complex, and I'm not entirely sure like how complicated our matching will be for this. So we'll just say like a list of pairs for now. Let's just say like simple like kind of times, or it could be like 7 columns of like 14 columns of like int try that again. Kind of messy, but like an array of time, like int 14 or something. So like open close times for every day. Let's go with that, yeah.
Mm-hmm. Okay. So, what do we have here? So can you just walk me through the whole flow when it comes to, okay, I load up this app, what happens?
Yeah, so like when I load up the app, like I open the app, the first thing there's like a loading panel probably, and the front end would make a request, the back end for like a list of restaurants. And then the backend would query the database with like basically a select star from restaurants, and then the database would return back a list of restaurants as database like output, and then the backend sort of formats it into like let's say like JSON, and then sends it back to the front end, and the front end would basically process that and like display it.
Okay.
Yeah.
So, okay, this works for probably one user. Like, do you think it? If we had 5 million users or 100 million users, this system will hold up?
I guess probably not, because like the backend is just hammering the database, so it'd be a little bit sketchy.
So it's just too many queries on the database?
Yeah.
Where else? Where else can it fail?
I think it'd also probably fail from the backend to the front end. Like I think in general, like both like the two links here, like between backend and front end and backend and database could like fail theoretically, I think.
Like what can fail on the backend?
I guess the backend server just gets overwhelmed by like requests. And like it has to take time to like service each request.
Okay. So how are you gonna solve that problem?
I mean, I think the database communication one's probably a bit easier. You could have some sort of like cache, I think.
Let's solve the back end. What
Like back and front end problem
Yeah.
first.
let's solve the back end. Yeah, like what happens? You're right. What if we have 1 million people, they all hop on the app, and we have one back end has to service all of those requests.
Hmm. I mean, I guess you could have like some sort of like load balancing maybe.
Okay, how would that look?
So you have like,
How would that look on here?
I feel like, so you would have like multiple backend servers. So I don't know how to like make this like, does this drag everything? Okay, no, this only drags this. But like I think from like a load balancing standpoint, like you probably have like some sort of like maybe some like central like load balancing servers.
Mhm.
Like, I guess you need some kind of like you need at least like one sort of like I don't know how exactly you would set up the routing for this, but like suppose we had like a load balancer that's like specifically made to like just like route requests. So ideally it should be like fairly optimized for that.
Mhm.
I guess you have like a load balancer.
Sure.
And then that would just start up like multiple like backend servers. So I'll just like use that with display that with like these little rectangles. Let's say like 3.
So the load
And then
balancer
it'll-
is like hitting all three. Like it's talking with all 3 of these.
Yeah, I think it could probably just like I mean like how it chooses to balance the load is sort of like up to like
Yeah.
you
What
just
are the
choose an
different
hour.
options?
I mean you can do like round robin, just like send the request. You can send them randomly, which I think in practice is probably about as good. I feel like the best option is to have some like adaptive like thing, like for example like maybe like when you send a request to the backend, the backend replies with like the number of like tasks that it has like in queue or something. Or like the backend collects like average like response time like metrics, for example. And then the load balancer could just like pick the one that has the lowest like response time each time.
Okay, that makes
yeah.
sense. Okay, so we have a load. We have our load balancer here. Okay, now how do we how do we handle what you mentioned, the database being overloaded now?
Mm. Just use Redis. That's my guess.
Okay, how would you use it?
Yeah. So I guess we'll just instead of saying Redis, we'll just say like it's like a cache of the database.
Mm.
I mean, what we could honestly do is like I think at this point we could probably just say like cache. I guess what would a map be? I mean, I feel like a map would just be like query to like answer. So like very simplistically, this works pretty well, I think, for like our current use case. I feel like what would our cache store? I'm not even like entirely sure, I'm gonna be honest. Because like one of the issues is that like this works like query to answer works well in our case because we only send one query.
Mm-hmm.
That's for all the restaurants.
Mm-hmm.
But like I think in the future, like we probably want to expand on this. So I'll keep that for now, just for like simplicity's sake. But I think definitely I want to flag that as something like we probably have to change. But yeah, so like I guess the backend will create the database. I think like the cache would probably have some like sort of like a live time. So it's like a live time for each entry. So like if the entry gets too old, just delete it. So like this like the main reason for this I think is like if like someone decides to add in a restaurant, like we want those changes to be like replayed onto like the back end and like the front end like within a reasonable amount of time. So like if cache entries expire, then I think it will help with that at least.
Okay. So what's the so it's gonna cache like the full query string?
Yeah, I guess it'll just cast a query string. I mean, like this is pretty simplistic, and I think there's like better ways to do it, but
Okay.
like for this purpose specifically, it works. I think.
Okay. All right. Pretend we needed to start. We have a lot of restaurants, and we needed to allow them to search by category. How would you implement that?
Okay. So I want to search by category. So I think this design is still like pretty similar. So like the US sends zeros for categories. I feel like this design still works. Because like there's still a somewhat limited number of queries. Like, how many categories of restaurants are there? You know, like as like a hypothetical.
Mm-hmm.
I don't think there's like that. Or how many categories?
Sorry, yeah. Let's ignore the cache for now. Let's say that from the front end they just query by, or they just be like search for all Chinese restaurants. Could you walk me through the flow? Of
Okay.
What happened?
So I think the main change now is like when the front end sends a request, it'll be like slash like restaurant slash like Chinese, for example,
Sure.
instead of like just slash restaurants. It'll be like slash restaurant slash category. So the same routing stuff happens. The load balancer sort of picks a backend server to like query from. And then the backend like would probably just do like slash restaurant slash category. So like it'll route that URL to the correct like path. Like suppose we're using like Flask or something. And so it'll parse the parameter out. And then I guess like for the next step, it'll probably query the database. So it'll use that category. Like it'll like select like star from like restaurants where like category equals like I don't know like
Pretend our
how to-
database had 10 million restaurants
uh-huh.
in it. Is there anything?
I mean,
how would your query perform? Like the select star where category equals category.
I mean, this would be like relatively slow, but it's like I think like if you want all of the restaurant data, like I think this is like the only like
Oh, no, but
like way you
we're
suppose you-
filtering by category now at this point, right? We want
yeah, we're filtering by category. Yeah.
So, pretend we had 10 million restaurants in general.
Mhm.
What would like what would happen here?
I think in general, like initially it'll be like pretty slow, where it's like the first few backend requests will hit the cache, and the cache is like will like it's like the backend request will hit the cache, like there won't be a cache entry, so it'll like request for like a subset of the 10 million. So like maybe like I don't know if there's like 20 categories and like average like 500k restaurants per category. So it'll still be like pretty slow, and then I feel like it'll like speed up after the cache like caches all of the possible
Or, I
categories.
mean, let's ignore the cache for now.
Oh, sorry.
Because like pretend on the first hit, because the cache is not populated until after the first hit, right? The second hit for the same exact query.
Yeah.
So let's ignore the cache for now, because cache is pretty much only useful if we're asking the same query multiple times. But I think when it comes to like a million people using Yelp, each query is going to be slightly different because they might be in slightly different locations and stuff like that.
Yeah.
So it might not be as useful. So let's kind of ignore that for now.
Yeah.
Let's just say in general, we have 10 million restaurants in our 10 million businesses in our directory, and we want to look for all of them with category equals Chinese restaurant. Is there anything that you think is gonna do you think this query is gonna perform based on how your database is currently set up?
I mean, probably not. I feel like you could create like an index, maybe. Like you could like index it by category.
What would that do? Like, how would that help? Or like, why am I saying it's slow without the index?
Because like I think any query would have to look through the entire set of restaurants. I think, right? Like it would have to search through everything to find like the category. Even if like say like I don't know, you want like what's like a type of food that like people don't eat?
Filipino food.
Huh?
I was like, Filipino food.
Well, I feel like Filipino food's pretty good. Like I get like sometimes. I mean, I guess it's like less popular. I mean, yeah. Suppose like if you search for like a category of food, it'll still look through all of the entries. I think.
Like, how does the index work essentially, and why would it speed up your? Why would it speed up here? Yeah.
I think an index would help because I think my understanding is that it sorts by like the key that you sort of give it to the index. So you could do a much quicker search. Like you could say in theory, like you could do like a binary search for like basically all of the like for like where like all the like the indexes for like the restaurants of like a certain category belong to. Let's say like you said you want like Chinese restaurants, like where all the Chinese restaurant entries are, and you get like basically a list of indexes. And so instead of having to look through all of the entries, you only have to look at the ones that you want to return. So like your runtime is sort of bounded by the number of like outputs.
Okay. Yeah. Okay.
Yeah.
Now pretend. Okay, we're able to search by category. We have 10 million restaurants, but we still want to be able to just render the list without searching for a category. Is there anything that could go wrong with your system right now? With how you set it up before? Like pretend we have 10 million rows in this database and the front end just calls it select star.
I mean, it'd be pretty slow. Are you saying like pagination or like some sort of like lazy loading where it's like
Like pretend I load up Instagram and it just shows me the whole database on my
yeah.
front end, right? Yeah.
I mean, it'll still be pretty slow.
It would
Like
be slow, but maybe like is it a good user experience also? Because
I mean, it's
like
pretty.
how long will it take to load all that data? Pretend 10
Yeah,
million
it'll take.
directories.
Yeah, I think it'd be slow both from like a backend standpoint, also from like I mean, it's also probably kind of bad from like a security standpoint, maybe, but also from like a standpoint of like as a user, like your load times will be very long,
Mm.
like when you're looking at stuff, and also like the app will be probably be quite laggy if you have like
Mhm.
because it's gonna be like very like resource intensive.
Yeah, and pretend I only look at the first 6 or 7, and then I leave the app. Is it like a waste? Isn't it a little bit of a waste of
Yeah, I
like
mean, I would
data?
agree. Yeah.
Yeah. So it's like how could we optimize that?
Mhm.
And honestly, sometimes even if you send 10 million rows back to the front end, maybe it might even crash out on the memory. Pretend like each request handler only can handle 5 megabytes. Like pretend it's using Lambda. Sometimes those have memory constraints, and you load in the whole database, it might crash out that Lambda or request handler.
Mhm.
So yeah, how could we fix that here?
I think in this case you could probably I think I was thinking like you could like in general for queries you could probably add like a query parameter. So I'll just say like this applies to both the front end and like update like both of these. But let's say like we'll say like start index is equal to like L and like n index is equal to R. So like the idea here is that the front end can sort of request a specific like list of like a specific um like range of like indices, and the backend sort of like will have like equivalent logic. So the backend will sort of process and like route it, and it'll like see like the start and end index.
Okay, how
So
would
I
the
think in
query
this-
change with the L and R now?
I actually don't know what the specific keyword is for this, but I think you could probably like drop start index and then like take like index like this. Like I don't know the specific words for this, but like I feel like this seems like a doable thing in SQL.
And what it's gonna say? It's basically that's saying start at the start index and then start
Yeah.
and then go all the way to the right index.
Yeah.
Yeah. Okay. Let's see. Let's. So we have a list of restaurants. It's displaying a list of restaurants. Let's work on the next part now. Displaying within a radius. So let's say that each restaurant has its address.
Mhm.
Has an address now.
Mhm.
And then yeah, from the front end, maybe you just know the person's address and it just gives me all the restaurants in a 10-mile radius or 10 kilometer.
I see. I see. I
How would you
think
implement that?
what I would do in this case, I feel like so I guess first we want to add like maybe like a long longitude, which is maybe like a float, and then like and then a latitude, which is also going to be a float, and then the address itself can just be a string. So the address we're not going to search like based on that. We're just going to like use the longitude and latitude of the actual location. So I think at the front end, so front end like what it will.
Mhm.
like front end, what it'll do probably is I think it'll probably record like sort of like monitor current location, uh, like based on like your like GPS values, and then it'll probably also like have like a like I think it'll calculate like the coordinates here. So I think there's sort of like two ideas that I have in mind right now. I think one is probably better than the other one. What you could do is you could just send your location and the radius that you're looking for to the backend, and then the backend would just send like a very simplistic query where it's like, search for all restaurants where location satisfies like where like this example is like latitude minus like current location,
Yeah.
like squared or whatever is like less than the radius. I don't know exactly what the latitude longitude calculations are, but you could just have like a math equation for that. But I think that's going to be pretty slow because you're going to loop over like all the restaurants, and you only really want to loop over ones that are like local to you. So I think let's do this. So I guess we'll add more query parameters for now because I think this seems like a better way to do it. Maybe we should just have query parameters instead of having like endpoints. But we'll just say like long is equal to like x lat the y, and then radius is equal to r. Is sort of what we have here. And so what the backend does is that instead of querying for this query, what it'll do is it'll ask for where the longitude is. Where's this again? So yeah, so x and y. So x minus r is this in longitude. And so what this does is that this does like a rectangular query for the restaurant. So instead of like Euclidean distance, it does like a rectangular query. And the idea is that this is like a list of all the restaurants that we care about, plus like a few more. But like the idea of this query is it should be a lot more efficient than just querying for the math expression itself, because SQL probably doesn't have a very good way of optimizing it. So you'd rather like give it like a query that it can optimize pretty well. And then so and then the backend will also, before it queries the database, it'll like search, it'll like eliminate like restaurants that aren't in the radius. So then you get like the correct values, but it should be more.
Okay. So we're gonna pass in the query parameters, we'll pass a long and a lat, and we're gonna do something like this.
Yeah.
So okay. Is there anything that could make, or is there any reason that this could be inefficient, this query?
I think it seems like relatively reasonable to me. I think we could potentially add more indices, I think, for like the location. I think adding indices for the location is probably good.
Like for the long and lang, or long
Yeah.
and lat?
I think just because I see that being like people are probably going to see restaurants near them and not just restaurants generally, I think. So I think adding an index for those two would be good.
Okay.
Yeah.
Let's see. Pretend we had like 10 million, or pretend all of our restaurants were in this map.
Mm-hmm.
So how would this? So what is what's longitude? Longitude is the x coordinate, right? Like here.
I'd actually remember
Something
but
like that.
Probably.
Okay.
Yeah,
pretend
that's your longitude is first.
We're
so-
looking for the longitude in some range, right? So we're gonna query
Yeah.
all of these. So we're gonna query
Yeah.
all the business in here, and then we're also
Yeah.
gonna query all the businesses and like find all the business in the lat.
Yeah.
And then we're gonna finally figure, is this like the query is gonna do something like that?
Yeah, I think that's probably what's going to end up happening. I don't like it's like ideally we have some kind of like two-dimensional like data structure that would like query just specifically within the range.
Mhm.
I'm not sure if SQL has a feature for this. I mean, would you rather that I assume that such a feature exists, or I could explain like maybe how you can implement this from like a data structure standpoint?
Maybe okay. Imagine. What is it? Longitude. Okay, I messed these up. Okay, longitude is the y-axis. Is that?
Or I have longitude as the x-axis, but I don't think it really matters like which one.
Yeah,
is
it's
which
like,
one
yeah,
is
it doesn't
y.
matter. Like at the end of the day, it's gonna do this big query. But
Yeah.
someone in the chat said that.
Oh, I see.
Okay, assume it was a 2-dimensional. How would that even work? Like we had some 2-dimensional representation.
Like index. I mean, you have like a KD tree, for example, which can do, I think, range queries in like something like 2D range queries. I think in like log n or something like that.
Mm-hmm.
Like log n plus like the answer. So like if you think of like a regular index as basically being like a one-dimensional like B tree, then querying for anything like across the index would take like basically a logarithmic time.
Mm-hmm.
For like a KD tree, that's indexing across both x and y, then it would be able to do a query across both dimensions in like the same time of complexity.
Okay.
So I think that's sort of what
I'm looking at the database now, and we still have one database sort of handling all of the queries. Like pretend we had, like Yelp is huge. It could like pretend we had 300 million active users. 300 million active users. How is it going? How is this one database going to be able to handle that? And we could assume people's queries are very unique. So, as in, not since we have all these parameters. I mean, you talked about introducing a cache, but like if the queries are very unique per person, then there won't be as many cache hits, I think. So that's where my rationale is like. So that's what I'm thinking. This database is just going to be getting hit a lot. Is there any way that we can reduce the load on this database?
I think we could probably shard it across a category. So I think there's like two ways I think of sharding. One is just you duplicate the database across like multiple venues, and so you can have like additional like load balancing logic, so that different backends will ask different databases for information. Alternatively, you could just shard the data, so like each database contains like just a subset of the full data, and we can sort of assume that people don't want like all of the data like at the same time. Sorry, like people don't want to like generally don't want to do like extremely long like analytical queries that query the entire database, for example.
Wait, sorry, could you repeat that?
Like I think like this for the second sharding option, I think it's just like you split the data across different databases.
Sure.
So that like hopefully people only need to query one database for data, like ideally.
Okay. So you're talking about we're gonna split the database, and how are we gonna shard it? We're gonna shard it by category.
I actually don't think category is the best one. I think because one, like different restaurant categories have different amounts of hits. Like I'm sure people like really like, I don't know, like fast food, and people like McDonald's, right? So that's gonna get like a ton of hits. But like maybe like more obscure food types like won't really get that many hits. So that's kind of like not really fair for like sharding the database. I feel like, in my opinion, I feel like location is a better hit. Also because I think people will query for multiple categories. Like a lot of times when I query for restaurants, like on Google Maps, like I just ask for restaurants near me. Like I don't really care about the category. So I think it's probably more wise to shard it by location than by category.
Okay. Nice. Okay. How would that look like? Could you upgrade your design for that?
So I think there's sort of two potential ideas. I think like we could probably have. I'll just like start drawing like squares. So we could probably have like a bunch of like squares, basically like these like little like baby like these are more databases. I don't want to make them the same size, but it's fine. Like these are basically just more databases, and like say each database like database ID will be like X, will be like it's like chunks of Minecraft. Like you have like a chunk X coordinate, like a chunk Y coordinate, and then that service is all like chunk X times like I guess like range like size plus like to like chunk X plus 1 to like chunk X plus 1 times size, and then like service is all like chunk Y, I guess times like probably Y size to chunk. So it changes like X size. So something like this. It serves like all coordinates that are within this range. So this is not like perfect still. Like you could still get multiple queries, and it's possible you might have to query like multiple databases. But like ideally, like this is like not as bad. Like you only have to query like a small number of like databases
Mhm.
to construct a query.
Okay.
So you have like a grid of databases, basically. That's what I'm saying.
So we have a grid of databases based on coordinates.
Yep.
That's how we're sharding it. And then, so the backend sort of calculates the chunk or which
Yeah.
database.
Yeah. So I guess backend calculates like, backend calculates chunks required, needed for query. Queries all DBs. Queries need necessary DBs for restaurants. And then we eliminate restaurants that aren't in the radius and send those back. Yeah. Okay.
Okay. Why not like just partition based on like city or something?
Yeah, that works too. I think like I just like wasn't. I mean, I feel like partitioning with city is like a bit more like it's a bit less like systematic. Like it's a bit more like, or actually that's. Oh, that's actually probably better. Yeah. Fair enough.
Okay. What if there's like a super busy city? One super busy city.
I think you could like subdivide into regions as needed. Like I think you would have some sort of like analytics for like how much flow goes into like your databases, and you could split the city into like chunks.
I see.
Like for like Manhattan, like I don't know, like you have like New York. Okay, well New York is too much. Let's split into like the 5 boroughs, and then okay, well Manhattan still gets too many hits. Then we can like have like Upper Manhattan, Lower Manhattan. Like you know, like,
Okay.
I think there's like rhyme and reason I think to this.
See. Okay. I think we have a lot here. It makes a lot of sense. Let's like work on cleaning it up a bit. As in, let's just make sure we have our functional requirements like ironed out. So we're able to list all of the restaurants by name, description, category. Okay. Let's just make sure we capture everything. Plus supports pagination. Display of or filter by category. What else do we have here?
I think filter by. Hold on, I gotta type. Sorry, I'm having a bit of issue with using the type tool.
Filter by location.
Yeah, by location. Yeah. I guess I'll probably put pagination as like a as also one of like the as like a separate feature.
For all of them, right? Yeah. I guess.
Yeah, that's worth.
Okay. So let's clean it up a little bit by, or I mean, I want you to sort of, you have this endpoint. Can you like format it better? As in, display me like maybe what are the different verbs we're gonna be supporting for HTTP, the paths, and then the headers in the body.
Okay. I think as far as this goes, I feel like because I feel like all of these query parameters are sort of additive. It's like you could query by category, or you also might not, or you could like query by description, or not by description. You could query by category, or you might not, or you could query by location, and you might not. So I think from that standpoint, I think it makes sense just to have like query parameters. I think instead of like like paths. So it'd just be like /restaurant/ like basically so I'll say like quote and like category. Category. I'm not sure how you want me to format this, but I feel like this is like somewhat reasonable. Like
what
it's like
HTTP verbs are you do you need to support for each like resource?
I think just get, because the users are just reading data. So I think we just need to support get from like a user side. From like an admin side, I guess post, delete, like put, delete, like all the other like types, but like it's not entirely clear to me like what the admin interface like has to look like necessarily. So from like strictly from a user standpoint, I think get's the only point we really need to support.
Nice. Okay. I think
yeah.
we're at 40 minutes, so let's just stop it here. How do you think you did? How was that?
I have no idea. I mean, I think it went all right. But I really don't have much other input on this. Like, so,
Yeah.
like I guess like what is your like overall feedback? I'll just like jot it down.
I think honestly you know a lot of things and you're able, but I think you're kind of all over the place. I think we need to be more systematic with it. So let's just walk through how the interview went and then where you could improve.
Mm-hmm.
So we started with the functional requirements, but after you list the functional requirements, you need to then list out the non-functional requirements usually.
Mm-hmm.
Because the functional requirement is what your system just needs to be able to do, but non-functional are all of the other things. Like, does it need to be scalable? Does it need to be reliable? Does it need to be fault tolerant? Like, how much latency can they have, or can we have on the front end, right?
Mm-hmm.
So just talking about that up front, like the question that you should ask after you should be like, what are all the things that we need to design, or what are all the features? Then you need to ask me, what is the scale of the system? If I say it's 300 million users, then you need to that's important information because that will affect your design.
Mm-hmm.
So I think you started off with a very simple client server architecture with a backend.
Mm-hmm.
That made sense. That makes a lot of sense for a for especially a junior candidate, but also, and it makes sense for anybody at any level, as long as they say that this will probably not work for 300 million users or the scale that our system is going to operate at.
Mm-hmm.
So I had to prompt you on that. So I would suggest that you probably kind of knew it up front, but maybe
Mm-hmm.
weren't thinking about it on the spot. But
Mm-hmm.
if I had to
Yeah.
prompt it, then I would assume that you didn't think of it up front on your initial design. So a lot of times candidates would be like, okay, I'm gonna start off with something simple. Obviously, this is not scalable, but as we go on, I'm gonna make it more scalable, right? Instead of like have it or list out the whole diagram and be like, okay, how does this look to the interviewer? And then like, oh, and then I was prompting, I was like, where can it break? And then you were like, okay, it might break on the back end because its back end is servicing too many requests, or it might break on the database because it has too much load on the CPU with all the queries.
Mm-hmm.
So I think saying things up front of where it's gonna break. So usually you want to follow a certain process. I think yours is kind of all over the place, and the process I like to follow is coming up with first the requirements and then the non-functional requirements, and then I start trying to list out the API endpoints and then make sure that all of my API endpoints like serve the functional requirements. So I have an API endpoint for coming up with the list of restaurants. I have an API endpoint for filtering, or maybe I'll just use the same endpoint like you mentioned. But I'll
Mm-hmm.
iron out the APIs, and it all depends really how your mind works. Some people are more front end focused, so they work from how the front end request to the back end. Some people are more back end engineers, so they start building out the data models and start working backwards. But the way I like to do it is from the user perspective, as in, okay, I'm using this app. These are all the functions I need to have. So then these are all the endpoints that I need to create. From there, I figure out these are the endpoints that I need to create. What do I need to store in the database to make these endpoints work correctly?
Mm-hmm.
And then once I have that, then I usually start scaling up the system. So I think, yeah, just having more process in there. Does that make sense so far? Do you have any like questions on
Mm-hmm.
that?
I think that makes sense. I think like I wasn't really sure how to approach the interview from like a process standpoint. So I think I was
Mm.
sort of just like, I'll s- I think I have a tendency to overcomplicate things. So my approach is just I'll state the simplest design possible
Yep.
and then sort of like query for what the next step is and then just
That makes
adjust.
sense. Yeah,
Yeah.
but then also just mention that yeah, this is very simple. We'll talk about scaling after, something like that. A
Mm-hmm.
slide note or that. Or be like, oh, this query is gonna be really bad. Possibly we could work on an index after. Just saying things up front as they come. Um, and you don't even need to say it up front. but like pretty much after you go through your design, you stopped and you ask me, how does this look? Instead, you should lead the conversation as you write it. It's like, okay, there's some bottlenecks here. Do you want me to address some of these bottlenecks?
Mm.
Okay, so for what I would say for the API, you could be a lot more, you could define these a lot more formally. So what that means is like, okay, we're gonna have a get, and it's gonna be a restaurant. Spell that wrong, right? What is it gonna return? It's gonna return a list of restaurants,
Right.
right?
That's what I say.
What is it gonna have? It's gonna have maybe some query params. What are the query params? It's gonna have a category. Sorry, I can't spell. Which is string, right? It's gonna have a start index, right? Like define it. This is just where you can improve, because you actually able to define it, but where you can improve it is write it out how you would write it in like a technical specification. And once you get fast at it, you can do that really fast.
Oh, I see. So in general, it's like like I think it would be good to document this how I would write docs.
Yeah, exactly. Because you were saying a lot of things, but it's just formatting in this, or just actually making sure it's written down.
Yeah.
Where else?
I think it was like very like, I mean, I think you're right. Like it was very like word dumpy, which I guess is kind of expected because I don't really know them.
Yeah, you're just starting.
I don't
But
think
this is actually a good start. What else notes do I have? Yeah, it wasn't scalable at first, but when I kept prompting, you kept making it scalable.
Yeah.
Let's see.
Yeah, I think mainly I wasn't sure like what. I guess I see what you mean now. Like sort of like highlighting like the non-functional requirements at the start, as opposed to sort of like just kind of like going with like a design like over and over again. Because it's like I think in my head like I was sort of like, let's do the simplest design that like works and is like reasonably fast for the current requirements. And it's like I can see like how it's like I know how to optimize it. It's just like like I'm not sure what direction to pick, I guess, per se. Which I guess is where the prompting comes in.
Yeah. Let's see.
Yeah.
So I would say, yeah, definitely working or just making sure that you formalize a lot of things when it comes to writing out the API, even writing out the DB. Eventually, at some point, yeah, you're gonna tell me where the primary keys is. You're gonna tell me if it was more complicated, you should tell me exactly what are the foreign keys. If it needs indexes, you need to tell me where indexes would speed it up. So all that stuff. As you get more senior, you need to drive all of these conversations. You don't want the interviewer prompting you it, because it's basically like giving a hint.
Right. I see.
Yeah.
Oh, I see. So this is like pretty different. It's like you have to sort of like, it's like just understanding like what to do next, basically. Like
Yeah.
what next step.
Let's see. Where else could we go? Yeah, I think look into geohashing to understand how we're gonna look for longitude and latitude really fast. So there's the concept of geohashing. Once you know that, you'll be able to solve all these proximity system design questions. Yeah, I think my main advice would just be having a more formal approach. Like for example, when you're doing lead code questions, I need to clarify, then I need to work through an example, then I need to discuss one or more solutions, then I need to code it, then I need to dry run it. Like you have steps. So I think in this part, you're kind of all over the place.
I see.
But yeah.
I mean, I will say, to be fair, I think I also kind of do that with lead code questions. I think I tend to sort of like just like approach it sort of like in a competition, like you kind of just like you, once you have something, you just like try to like you sort of think about something, and once you have like a formal idea, you just like code it out. You like iterate on it, like on any steps that are sort of like unclear, like missing. But it's very much like sort of like ad hoc. Like you kind of just do it. So I guess I probably just have a much better handle of lead code questions. So I think it makes up for like the lack of organization.
Yeah.
But yeah, like I think here, yeah, like I see what you mean. Like definitely, like it's like there's a lot of like, I think it's also a lot more like theory. So it's like, I think like sort of like understanding the systematic like approach to like solving it is like pretty.
Yeah, But honestly, you understand all the concepts. I would just when you practice, when you practice by yourself, just work. I like how you do it. I do it kind of similar, where I don't give the most complicated design first. My
Mhm.
first design usually just makes sure I meet all of the functional requirements, and then I start upgrading the system to meet all of the non-functional. So I look at all
Mm.
the functional, I list out all my APIs, I list out all my database tables. At the
Mhm.
basic sense, I can serve the functional requirements because a lot of interviewers, or in a lot of interviews, if you just need to make sure you pass all the functional requirements, and then usually hitting the non-functional requirements are for more senior candidates. So I think
Mhm.
you're probably a pass here, but
Mhm.
yeah, make sure you hit all the functional requirements and then start scaling up the system to hit all the non-functional requirements. So it's all about just process and understanding the process. But I think yeah, like you're already know a lot of the stuff. It would just be more working through a lot of different questions and understanding them.
I see, I
But
see.
yeah,
Like, I guess this would be like like you said, this would be the sort of like a regular pass, like as far as juniors go.
mm-hmm.
Um,
Yeah. So
Makes sense.
how do you think? So what's your thoughts now with the feedback and like after I gave you or after I told you what I thought? Like, does that jog your memory
Mm.
on or like does that jog the conversation a bit? Like, how do you think you did now?
I think it was sort of like what I was somewhat expecting. I mean, I think it feels in line with in general. I think what people, I guess also like what you've said to me about like interviewing performance generally. I think it was nice to sort of like I think like maybe like a change in approach is like I sort of like I like the like I also like I still like the iterative approach of like starting with a simple design
Yep.
and sort of like scaling it up over time. But I think like probably the biggest point of improvement there is just to be more explicit with what's missing, as opposed to like I wasn't really sure I think what to ask.
Yeah.
Like sort of like what specifically was missing. So like maybe being more upfront from like just like purely like a specs requirement first, so that we have like a list of things to like refer back to during the interview.
Yeah. And
Um,
that's a big part of the system design interview though, is
mhm,
drilling down into what is actually required and what the interviewer actually wants. Because the system Yelp is so huge. When I said design Yelp, what I'm trying to see from you is how can you take this massive or this big requirement and then drill down into things that we could actually accomplish within our 45 minutes together. And that shows a lot about like your communication skills as well and like project
mhm,
management skills, etc. So like I might ask you this interview or this question and look for certain things, but somebody else might ask you the same question and might be looking for other things, right?
mm,
Like it's not like the system design is very ambiguous, so that's why it's on you to kind of figure out what specifically is this interviewer wanting to get to. Does he want to? In some of them, they really want to focus on the database. Some of them, they want to get the whole high level design. Some of them, they really want to just make sure that you're building something scalable, right? So, like upfront, you didn't really ask the scale. That's why, if you did upfront, I bet if you did ask that upfront, I bet that you would have had a different design in your first go.
mhm. Oh, that's true. Yeah, I guess yeah that would immediately eliminate the first design, and I think also the caching was kind of like kind of tossed it out there because I was just like how else do you speed up a database, but
Yeah,
um, yeah, that ended up not really being useful.
yeah,
Yeah.
cool. All right, let's do. We have to do our leak code at some point, so I'll send you another link to do. I already set up a couple leak code questions I want to ask you, so we'll do that
Uh,
next time you're free. Maybe like a
yeah.
month from now or even like 2 weeks from now. Just let me know. I'll message you.
Yeah, sounds good. Yeah.
Awesome. Good job though. Pretty good job,
Like,
especially you're still a student. Honestly, when I was a student, I could not even get close to doing something like that. Only when I graduated and had like some work experience, I could get something like this up. But good job.
thanks.
Cool.
I also want to thank you for just like impromptu like running a system design interview instead of leak code. Like I know you were doing like an 8 hour leak code marathon.
No problem. I just do whatever any candidate needs in order to prepare. I'll run that.
Yeah.
All right, man.
This-
Catch you.
All right. See ya.
Peace.
Have fun with the rest of your interviews.
Thank you. Thank you. Yo, chat, what's up? Y'all know what's going on? Yo, who's still here? Went ghost. Or no one's talking no more. Still a bunch. Yo, what's up? Yo, how was that? What is it now? 6. Yo, is it super cracked?
Can you hear me?
Yeah, I can hear you now.
Sick.
This is super cracked, right?
Yeah.
What's up, man? How you doing? Are we gonna do system design too? Is that what you asked for last time? Or no?
Dude. No, I think I'm gonna have to stick to lead code for now. I definitely need system design prep, but like, I don't even know the baseline right now for it to be worth doing it. You know what I mean?
Yeah. How was that? Like watching Plasmatic?
The first half I was doing a lead code question, but I watched the second half and yeah, it seemed good. Definitely something I need to start practicing, I would say.
What question were you doing? Damn, you're just grinding lead code on the side like
No, that was like the
On a
first,
Sunday?
or it's like the second question I've done all week. I have not had any time to do anything this week. It was minimum time to repair cars. It was some random binary search question.
that? Alright. Cool. Let's just hop straight into this. You're working at Pure Storage, right?
Yeah.
Okay, let's see this. Chat's asking, when do you need to understand system design for? You need to know like a little bit. You need to know a little bit of system design for new grad. If you're applying for new grad, if you're doing an internship and you just get converted, you just get converted to a new grad. That doesn't matter. But when I was a new grad, when I was applying and I didn't want to do any of my internships, convert any of my internships to a new grad, I had to learn system design, but very basic. The thing that the one that he did would be a little bit higher than a new grad, but maybe not a 2 to 3 year experience. It's like in between. Probably what I would expect for someone with like a year experience.
How'd you learn system design?
I like read a few books. So I read that Designing Data Intensive Applications book.
Okay.
I read a bunch like the System Design by Alex Zhu books. I had to conduct some of those interviews too. I don't know. And then I just was spamming system design. Also, I did a ton of new grad. Like when I switched companies, I did a lot of on-site loops, and all of them required system design.
Makes sense.
And then yeah, I don't know. But when you start working, honestly, you learn a lot of the concepts to do well in system design. Like when I was studying for system design as a new grad, and I was reading Design Yelp, it literally made no sense. Or it kind of made sense, but like it doesn't click the same as when you have experience already. And then you're reading how to design a newsfeed or how to design WhatsApp, and it just like everything just makes sense why they do certain things because you have a little bit of experience. All right. Hey everybody, so today we have a candidate from McMaster University who solved around 500 lead code questions. Yeah, he's been on here before, so I'll probably skip the intros and we're gonna work through the very first question. And you like to work on C++, right? That's your language
Yeah.
of choice.
Yeah.
Okay, let's just hop into C++. So for the first question, I want to design a search recommendation system, search suggestion system. Can you hear me?
Yeah.
Oh, you might have lagged a bit. So pretty much, I'll show you an example.
Mhm.
So we're gonna have a bunch of products, and then we're gonna have a search word. Pretend we search mouse. We need to design a system that suggests at most 3 product names after each character of the search word is typed. So pretend they're searching in a search bar, and they first type in M. It should suggest 3. It should suggest 3 suggestions, and I'll show you what it should suggest. So it should, for when they type M, it should suggest this. So when they type M, it should suggest the first 3 results in lexicographical order. So if there's more than 3, only return the first 3 in lexicographical order. So like MO, MOU, MOUS. That makes sense?
That makes sense.
Okay, I'll let you go.
Yeah. Okay. Okay, so what I'm thinking is we can probably just sort it and then kind of do like a pseudo binary search kind of thing on it to get those 3. So I'll try kind of run through what I'm thinking with this. So let's say, for example, we sort this, and then, okay, what would this look like first sorted? Mobile, then money pot, I think. And then monitor, right? That's correct. MOB, MON, MONI. Yeah.
Oh, you're lagging a bit. We can't hear you.
You can't hear me?
Okay, yeah. Okay, so what were you saying? Yeah, you lagged for a bit.
Okay, what I was saying is we sort it, and then for each letter, we kind of like reduce down our bounds. So, for example, here we would try and find like the start and end of where the M's are. So, for example, here, that doesn't really change anything. And we would just keep like our left pointer, like this would be like L, and then this would be like R. So then we print out the first 3. So we would get this, and then we would do MO. So we would also try and cut it down again, but again, everything is MO. So we just print out like the first 3 from that, then MON. And then this time we realize that we can move this L inwards to here, and we move to here, and we try like the first in the R range, and this time we get we do MONE again. Wait, or MON. Oh, yeah, MONE, and then we would move like R to here, and then we would just get money pot, and then if we did money,
Okay, so how are we moving these bounds? Like how are we finding where to put left or where to put right?
well, obviously, like naively, we could just move them in, like in O of N by just checking, you know. So like, let's say our thing was M, we just check if this has M, and then same here on the right, we just check if this has M, and then like on O for the same one, we know everything in this range starts with M already, so then we can just check if the second letter is O. If the second letter is O, and again, we don't have to move them in. Then here we know everything starts with M and O, so we check the third index, and that's not an N, so we move it inwards, and now we get here. And same with and that would be there.
Well, is your what's it called? Your like AirPods or something dying? I don't know.
No.
Okay, it's just it's lagging a bit, but it's okay. Like it lags out for like 30 seconds at a time.
30 seconds?
Or not 30 seconds, like 10 seconds. Okay. But like okay, yeah, is there anything you can fix on your side? If not, it's all good.
Can you hear me better now?
Yeah, I can hear you again.
Yeah.
I can hear you. It's more that it just cuts out sometimes. Robot and yeah, people chat said it's like roboting and then speeding up and down. But it's all good.
Okay. I switched the Wi-Fi network I was on and rejoined, so hopefully that fixes it.
Nice. Cool.
Did you hear my like naive approach?
Yeah. Okay, wait. Let me just
Yeah.
let me restart this real quick. I'm gonna do a new recording just because the audio. Okay, hey everyone. So today we have somebody, and the audio was cutting out a bit, but what we're doing is we're designing a search recommendation system. We're working through a coding interview, and this is just the first part. So I'm just gonna delete, or let's not let me enter it here. But we're building a search recommendation system, and pretty much we're gonna be given an array of strings, products, like this, and a string search word. Like we're gonna be searching for the word mouse, like that, and then pretty much as each character is being typed, we need to suggest products with the same common prefix. So for example, when they search M, pretty much all of these have a M, so we just need to, so we could return all of these in our search results, but we only want to return the top 3 results, and we want those results to be sorted in lexicographical order. So like mobile, money pot, monitor, these are like the first 3 in lexicographical order, so we return that. And pretty much as we start searching, like MO, MOU, it's gonna filter down the search results. So your approach is gonna be, could you explain your approach again?
Yeah, so my first approach I thought of was just to sort the list right away. So we get this list here, and then we could kind of use 2 pointers to keep track of our bounds of valid words. And then since it's already sorted, we would just print out the first 3 from the left pointer, or if the right pointer is closer than 3, then we just print out what's inside that range. And this would be n log n for the sorting. And then for each letter, it would be an extra about O of n, because we would only eliminate or like check each word, I think, once.
Like what if it had like a long prefix like that? The words are big.
It would be like for all the M's, then this would still be in our range. And then same with the O. When we hit the N, then it would shorten down to this. Like we would check this word for every M, but only that word, and then we'd check this one on the right as well for every M to make sure the right pointer is still there. And then same for the O. And then once we got to the N, then we would check the N on this left one. It wouldn't be there, so we'd move it in one. And we would check for the N in Money Pot, and it would be there. And then for Mousehead, we would check just for the N. It wouldn't be there. For Mouse, we check just for the N. It wouldn't be there. And for Monitor, we check the N, and it would be there. So, like, we wouldn't have to compare the entire prefix.
How are we moving? Yeah, how are we moving this prefix? Like, pretend it was all the M's, it was like M star.
Mm-hmm.
For like, it does this for a lot, and then all of a sudden we're like MO. Like, how do we move it to?
Like, what I'm saying is we don't have to recompare the whole prefix. We can, since we know that the first whatever letters already match in this range, we can just check this one index, check if it matches. So it would be like an O of 1 check instead of like an O of n check for the prefix. This is just one solution. We could also obviously use a try. But I'm not sure, because there's a setup cost involved with that. I'm trying to think if it would be worth it, because for try we would probably do the same thing. We would sort it in advance and then insert every word into the try, and then at each node, normally we would just have like is end and next, but we could add a third member variable that would just be all the words with this prefix. And then since we insort it in lexicographically order already, since we pre-sort like the products, we would just return the first 3 from that node. So the try is also another valid solution. I'm not sure how much that would speed it up though, because it's still n log n for the sorting, and then that would still be, then for inserting each word, that would be like O of m, like for the characters in each word. And then, yeah, I don't know. Those are 2 approaches. I'm trying to think which one I think would be better.
Yeah, I mean, both seem to work.
Mm-hmm. There might, in my first approach I mentioned too, there might be, you might be able to cut it down to like a binary search-ish algorithm. I'm trying to think, because we're sorting it.
I pretend like the next one is O, and then we have to, like, there's a lot in between, then we're gonna have to increment this. Like pretend this one.
Yeah.
It might be less efficient than your second approach.
Mm-hmm. What I'm saying is though is, like, yeah, we would have to increment the pointers one by one, but that's still like O of n, right? Because we're passing over each word once. Like, once that word's cut off, we're never revisiting that word again. But yeah, I think I might like the try solution better, to be honest. Because how would the try solution work? We pre-sort, we insert it, and then we just have the extra member variable. So then at each, like, quote unquote query, like at each letter, we just move down the try and then return the first 3 in that list. That's going to be more coding, I think, to set up the try, but I think that just logically makes more sense, and like the code will look cleaner. I think that might be the better approach.
Okay, let's go with the try then.
All right. Okay, so we're gonna need a try node first of all, which will have. What will a try node have? Try node needs to have. So the next array, next, which is all the letters, so 26, and then it needs to have. Is end, and then constructor normally, is this how it works? Yeah, because it links, it links to the next node. So in our actual try, we will have our try node, which will be our root, which will just be a null pointer, because, and then to point to our first letter, we'll use the next thing. Yeah, which will be that. So then constructor. Yeah. So then what we're gonna need is get, I think, right, is that one? Try to get our C. So, and what we'll do is we will just return well, actually yes. Next at I equal corner. Try now. Oh, that's why this needs to be trying to pointers. Okay. So there's a constructor, and then we will return next at C minus A. Yeah, and then put then we want to put something in. What we need to do is we just need to do next at C minus A. Try node. Okay, so we have get, put, then we'll do bool is end, just return is end. Definition, yeah. And then we should also have, I think we need make end void make end, which just sets is end equal true. What method am I missing here? We need get, put, is end, make end. Oh no. True, I know. Okay. And then in our actual try, what we will need is we need to be able to insert words. So void insert, we'll take string word, and then yeah, so root. Okay, yeah. Try node P.
Did I ever fooled you before or no? Like give you a question that you couldn't solve or no?
Yeah, there was the one two
Is it the
interviews
validate
ago.
binary
about-
search or binary node?
Yeah, the binary search.
Okay.
I kind of fumbled that one. I might fumble this one. I kind of am not remembering try off the top of my head. I think I can get it, but it's gonna take me longer than I want it to. I already know. Yeah. Okay. So yeah, we need this try, and then to insert a word, we're going to need a pointer, which initially will be at our root, and then for every character in our word, we will just insert it if it doesn't exist. I think that's the method I'm missing in try node. I think I need to check exists. Yeah. Bool exist char c. Return get c not equal no pointer. Okay. So if not p dot exist c, then we will need to insert it. So we'll do p dot put c, and then either way we'll want to move down our links. So we'll do p needs to go to equal p dot get c. This like moves us down our try chain, and then that should be it. Oh, and then in the last node, actually, we'll need to do p make end. And then, yeah. So this is our insert, but normally you would do like search prefix or search, but what method do we actually need for this problem? Basically, for this problem, we shouldn't be researching every time. We can basically reuse our last thing. So let me think what I actually want to do here. I think what I want to do is I want to make a... Okay, so what I need every time is to return 3 names. So this will be a vector of strings. And I think what I want to do is I want to make a search from function where I can take in a try node and continue searching from that one. So I don't recompute the things already done. For example, if we've already done M and O, we don't need to research that prefix. We just want to start on the N. So I can pass in my node I got from O and search from there. So.
Well, when you're given the search string, like when you're given the search string, right? You're it's not gonna change. Like we're not gonna be querying it multiple times. Like you're gonna start off.
Oh, true. So I can just start from the start and build up my answer the entire time. Yeah, that's easier. Yeah, so this will be a vector of vectors of strings. Yeah, I'm just gonna search a word. String word. So at each letter, I am basically just going to, what do I want to do? Yeah, so similar to that, we need to get our pointer equal to root, and then let me copy this so we won't do what I don't need. Yeah, so each letter, if it doesn't exist, then I guess we just break. But if it does exist, then we are going to want to do, let's also make our answer here. Std vector, std string, answer, and we'll do and so push back. And what do we want to push back? We want to push back. We'll call it p.query. We actually need to implement this method. I haven't made it yet, but basically go back up to try node. What we want to have at each try node, as I mentioned in my very initial explanation, is we're going to want to have a vector of strings, which will be, what do we call this? Products, I guess. products, and since we're inserting in sorted order, we can assume these would already be here. So what are we doing? I think what I'm gonna want to do here is call put every time. Or no, what I'm gonna want to do here is I'll make another method, add product, which we throw the word into. Okay, so where are these methods gonna go? Yeah, so I'll do void add product, string product, and all we're gonna do here is products push back product, and then we'll add query, which will std vector std string query, and what we're going to want to do here is return the first 3 elements of this. So for I equals 0, I less than the minimum of 3 and product dot size.
It's 3U.
Yeah, that just means I'm sad. I think it should fix a type error, but I don't know. Yeah, less than that plus I res dot push back product set I. What's going wrong here? No matching function call to min. Requires 3 arguments. What? I'll get back to that in a second. But query, yeah, I should return the 3. And then we add each product. Okay, so you'll push back query, get C. And I think we should also have another check here. If P is equal to no pointer, and then we should also break. And then we do not need that. Yeah, so for character and word, if it does not exist, we break. And then, yeah. Actually, this should not be no pointer. There, and then there, and then this is not in the right bracket. Okay, so where's the error come from?
No return statement in the function or mismatch types. But those are just, they're not actually issues, right?
What is this min one? What? Yeah, so I less than the minimum of 3 or products dot size. Yeah, well. Oh, there we go. And then, and then return res. Okay, just running. I guess we should probably go
walk
through
me through line by line.
All right, starting from where?
Starting from the main function.
the main function.
Or sorry, like the function, the outside function where it's searching, and then they drill in deeper and deeper.
Oh, this one. Okay. So we initialize our answer array. We get our pointer to our root, and then for every character in Word, we check if this character exists. So if this character doesn't exist, this means that there is no words at all in our original product list that match this prefix. So we can just break and return what we currently have. Otherwise, we will push back p.query. So if we go to p.query, what that does is it grabs the first three, or if there's less than three, then that many products that are in this node. And the products array or vector is an already sorted list of all products that had this prefix, and we put them in there when we did our insertions. So it will return that.
The minimum of 3 and the size. What if there's not any, or what if there's 2 or 1? Or I guess
Yeah, so then it will return 2 or 1.
Okay. And then will you add?
And then we would get the next node.
Wait, go back to the. Let's go back to. Okay, you're running the query.
Yes.
Well, let's talk about inserting. Inserting first. Just make sure that the try is correct.
Mm-hmm. Okay, so on insertion, whenever we're inserting a new word, we start off at the root.
Mm-hmm.
And basically, if this character doesn't already exist, so if we haven't had a word with this prefix already, we need to put it there. Basically, what put does is it just creates a try node, like with that link in there. And then use the one we switch. Yeah, puts it there. And then get moves this like down to that character. So let's say we just inserted an M. When we do get, we're moving on to that try node that like actually has the M in it now.
Yeah.
And then we would add product. So in our products list at that M node, this product is now in that list.
Let's look at the add product. P.add product.
Yeah.
Okay, push back.
So it just pushes back the product.
Okay.
Mm-hmm. I don't think we actually need the make end or is end things for this problem, but we'll take that later if we have the time. Yeah. Yeah, and then it just does that for each letter. So it'll continue down, adding the letter if we haven't already made a node for that prefix, and then continue down into that node, and then adding our word to the product list for that prefix, so that when we query it, we can get it.
Okay, let's look at your try. So the try has a vector. It just has one next. Where's the list of next? Okay, so
list of them.
Next.
So that'll be like for each character.
Yeah. We say if it's an end. We say if it's a product. Okay, so for each one, we're kind of listing out the products.
Mm-hmm.
And we add product. Okay. Get. So when we're getting, we get C minus A. Yep. Exist. Is the end. Okay. Do we need this part of is the end or make the end?
No, I don't end up calling this at all.
It's all good.
I wrote it just when I was making the node because I think you normally have that in the try.
Okay,
but...
let's write some test cases.
Okay. So, yeah, we'll go to main. Let's bring down this test case you sent in originally, which is this. Okay. Okay, I'm down at the main function right now. Okay, so products and search word. So what we're gonna want to do is create a try. and then to vector string products equal to, okay, so try, and then for, let's just do for p in products, try dot. Yeah, so for auto p in products, try dot insert p. Actually, we need to sort this first. Sort products dot begin, products dot end, and then yeah, this should be min sorted by default, I believe, but I'll double check that after. Try dot insert, and then we should just be able to call try dot search. So say auto ands equal to try dot search mouse, and then or mouse. Okay, it looks like to me I'm missing one thing. What am I missing here? Yeah, so what's going wrong here? Do you see the terminal output? Like the first four correct, but we're missing the last.
Yeah.
What is it? Yeah, the last. What is it supposed to be? Mouse and mousepad. Yeah. So, okay, so let's see search. So for every character in Word, we check if it exists. Yeah. And if it doesn't, then we break. But, and we push back the query, which looks right. Then we move to the next letter. And yeah. What's going wrong?
It's just not putting the last one in, right?
Yeah. But I'm trying to see why. Will this fix it or not? No. No. Oh. Okay, if that does not exist, we put it there. Turn get C does not equal any pointer. Okay, and then equal to new try node. Yeah, that should be fine. So then
Well, it is at the end, right? The mouse.
Yeah.
So when you're at the E, there's nothing under it. So I think it's returning, but it's returning it empty. Your very last row, it's actually working, but it's returning empty. Because it's at the E, and E has no children, I think.
No, it doesn't look like it. Wait, let's see. Like, mouse. Okay, so it is going through all of them. Should be querying.
Or see out the response here too of the each query.
Mm-hmm. Yeah, let me go into query. Let's see. So, okay.
See, like the very last one, or your M is not returning anything.
What? The M is not. Fixed it.
Nice. Cool. Like right on time. We're like 4 minutes left till the end.
Mm-hmm.
How was that?
Yeah, that was a good problem.
Yeah.
Again, I didn't like how much debugging I have to do. I really don't like when my code doesn't work the first time.
Good job though. You just pulled out able to implement the try right on the spot.
Mm-hmm. Yeah, I was not sure if I was gonna be able to do that.
Yeah, probably just labeled this like making a candidate like do a try right on the spot. I don't even know. But, cool.
Mm-hmm.
I have to.
Is that how you're supposed to solve it? Is it supposed to be you sort it into a try?
People have done it the way you did as well. Honestly, I didn't look at what's the fastest try or which one's the fastest runtime complexity. Mm-hmm. I do the try. Okay, the binary search, that's the first solution. Try. It looked like the try one is way more efficient from what I see.
Okay.
Yeah, because like
I thought of try right away, but I was like, oh, maybe I can avoid not writing a try here. But then the more I thought about the first one, I was like, yeah, I think we're just gonna have to make a try here.
There's a binary search example, but then there's also just a try example. Yeah. Mm-hmm. People just do the try.
Yeah,
I like to do the try for that one.
Yeah.
Cool. Thanks for implementing that. I'll catch you again.
Yeah, of course. Thanks for interviewing me.
No problem, man. Peace.
Peace.
All right, chat. I have to take a quick break. My eyes is burning. Give me a sec. To take a quick break. I'll be right back. Then we have our last person from Taiwan. Yo, what's up?
Hey James,
How you doing?
It's been like a month-ish.
Since I interviewed you?
Yeah,
Yeah,
before. Yeah.
that's crazy. What did I ask you last
A
time?
few things
Jared?
have changed. I moved, so and then I got like interviews coming up for Google and Amazon. I think Google
Nice.
is much harder though. They said like 2 mediums or 1 hard in 45 minutes, and it's to be solved like perfectly optimized. You can't get too many hints. You can't get the time complexity or space complexity wrong. Like,
Yeah.
yeah.
Where are you based now? Taiwan or you changed?
Yeah, now I'm based in Taiwan. Before I was in Texas.
Oh, what? That's a big change. What?
Yeah, yeah.
That's weird. Wait, I'm just gonna grab something. Give me 2 seconds. You've solved over 1,000 leak code questions?
Yeah, but remember, like it was mostly easy and medium. Like
Oh.
hards are barely any, like 30 some.
What time is it there?
11 a.m.
Okay, nice. That's not bad actually.
It's like almost like a 12-hour difference usually.
All right. Okay. I'm just getting. Looks like just getting set up. Wait, can you say something? Just need to test my mic.
Let me see.
Also,
Should
what
be-
language do you code in?
Python.
Okay. Okay, I sent you the CoderPad link.
Yep, I see it. And let's see. All right, let me. I should have. Yeah, I should be in, I think.
All right. Okay, I'm gonna get this started. They have Google and Amazon in Taiwan.
Surprisingly, yeah. I know Google was there, but like Amazon, I think is Ring AI. So like that.
Are you
I
okay?
think Amazon was like the Ring AI department. Is
Are
here
you
in
working
Taiwan.
right now, or you're just full time?
No. Still applying. Like I have an offer, not big tech or anything, but it's
Yeah.
like close to where I live right now. And I just want to see like if I can if I can proceed further with like interviews for
Yeah.
big tech.
But where'd you graduate from?
UT Arlington.
Okay. Were your plan always to go back to Taiwan?
I mean my parents are here, so
Oh yeah, makes sense. Cool. All right, I'll start this up. Hey everyone. So today I have somebody joining in from Taiwan who solved over 1,000 leak code questions and has some incoming interviews at Google and Amazon. So yeah, we're here to help them prepare. How are you feeling about these interviews?
the way the recruiter described it is going to be really tough. And since I mostly solve medium questions, I feel like if they give it hard, I'll just panic and not know how to proceed.
Yeah. So what have you already done for these 2 interviews? Have you already done like a tech screen and then now you're doing the on-sites for both of them?
I think now it's just all virtual on-site.
Wow.
Yeah,
So
I think like Google has like 3 coding interviews, but the first one, if I don't do well on the first one, there won't be anything, like there won't be the rest. But if I do well enough on the first one, then I get the other 3 interviews, which is total of 4 rounds.
Yeah.
So the first round is coding, and then 2 coding, and then 1 behavior, assuming everything goes well. That's for Google. But it's like an L4, so I think they have like higher expectations.
What about for Amazon?
For Amazon, it would be new grad, so they didn't really explain the difficulty, but I think it's not as difficult as Google's for sure.
Okay. Okay, if we want to prepare you for Google and Amazon, I'm gonna have to find you some good questions. Give me a sec. Let me find you some good questions then.
Okay. Like last time, I think you helped me understand like backtracking. I don't know if you
nice.
remember because you do so many interviews.
Yeah, I think I remember that.
Yeah, you helped me understand backtracking better, and we didn't have that much time. But the other one was like an island DFS type
Yeah.
question.
Someone's asking what makes a competitive resume for an internship. I don't have internship experience, just been grinding leak code and working on projects. What makes a competitive resume? Just having having a well formatted resume, having any projects that you're actually worked on there that are relevant to the internship you're applying for. Other things that help are if you don't have internship experience, like clubs, coding competitions, coding clubs, hackathons, whatever. Just other things to supplement the resume. But let me get in. I don't know if that answers. When is your interviews?
Google will be like Thursday, and Amazon they said they would get back in me like in a week supposedly. It's been like 5 days.
Okay. All right, so this first question. So in this first question, what the goal is, we're going to be given 2 non-empty linked lists representing 2 non-negative integers. The digits are stored in reverse order, and each of their nodes contain a single digit. We need to add the 2 numbers and return the sum as a linked list as well.
List. Okay. And any leading 0 except the 0 itself. Okay. So I guess
So this is the first. This is one
Yeah.
example.
example. Okay. So given linked list 1, linked list 2, true for 3, 5, 6, 4, because it's reversed. It's 3, 4, 2, and it's 4, 6, 5. Okay. So once you get added, and then returned. Okay. So we don't have to. Like reverse the linked list. Okay, because the output is also reversed, so we don't have to reverse the output again. Okay. Similar to no leading zeros. So by leading zeros, it means like nothing like this, right?
Yeah.
Like 2, 4, 3,
Yeah,
0,
yeah.
because it will be leading 0 to the right side. Okay. In that case, I think I can loop through both linked lists at the same time and have like a carry variable. If carry is 0 or 1, and while there's still a number left for L1, L2, or carry, I just keep going to the next, and then add the 2 numbers together plus the carry. If it's greater than 9, then I have to put another carry will be equal to 1, and then I can move on to the next one, and then append a new node, and then return the whole new linked list. I think that can work.
Okay, makes sense. Go ahead and implement.
Okay. So let's see. Probably want a dummy node. Do we know what the node class looks like, or
You can create it yourself. Like figure out, or what was gonna look like. Yeah, you tell me. Like
okay,
you could define that.
probably okay, then probably a this node and let's see, we will need a value and the next, so value and next node. So self dot value equals value and next equals the next node. That should be okay, I think. Yeah, just the value and the next node, and yeah. So if I do a dummy node, that should be okay. Oh, but do I need to create like a
Yeah, create me a function that takes in two
yeah.
lists and it will return the
create
output
a
list.
function, right? So call this add list. So we have L1 and L2, and then return a list node. So, okay, so I need a dummy node that starts, and then a carry, and then the current node. Then dummy dot next equals current. Then, well, L1 and L2 and or carry. While they all have values, then I want like a new value is L1 dot value plus O2 dot value plus carry. And then if the new value, well, actually, the new value and then the current value needs to be new value mod 10. So it needs to get less than 10 value for the current, and then let's see. Carry will become new value divided by 10. And then I need to check if L1 exists. So let's see, L1 equals L1 dot next if L1's still dot next if L1 still exists. But actually, what if can L1 be just no values?
Are you saying like what if they're different sizes?
I think they can be different sizes.
Yeah, they
That should
can
be
be-
okay. It's like if L1 equals this,
No, like each one of them has at least one element.
has at least one. Okay, has at least one. Okay. So first one. So
Two, yeah,
next
two
is-
non-empty linked lists.
Okay. Next, if L1, okay, I should probably be use like V1 and V2 then. V1 equals L1 dot value if L1 exists, else it's 0, and same with V2 if L2 else is 0, and have V1 plus V2 plus carry, and then become when L1 gets next, if L1 still exists, else is none, and same with L2. Okay, so current value is safe, but now I need to move current to current next. But I think I should declare it, or no, I think okay, maybe I don't even need it. I'm overthinking some of the order for the list nodes. So it would be current dot next equals a list node of I don't know why it's saying that. Okay, yeah, a new list node of the value, and then I can go to the next, and then once L1, L2, and carry are all 0, they're all none, and carry are all 0, then this will break out. Once it break out, I can return dummy.next. So I think that's the overall logic. But I'm gonna do a dry run just in case and check. So let's do a simple example.
Yeah, do like 9 plus 12.
9 plus 12.
Or
Okay.
something.
Let me, 9, and then L2 equals 9 plus 12, like that. Okay. So
It's gonna be more like in
gonna-
reverse order though, so 9.
Oh, right.
Like 2.
Right.
Yeah, walk me through.
Okay, yeah. So L1 is 9, L2 is 2. So they all still exist, and carry is 0. And then L1 gets the value 9 because it still exists. L2
Wait,
gets
walk,
the
walk
value
me through
2.
here, line 30. You create the dummy.
Okay, yeah. Create
set
a
the
dummy
current-
node.
The dummy, okay.
And then I keep track of the dummy node in current. And then I initialize carry to 0. And then while L1 node and L2 node or carry exist and carry is greater than 0, L1 and L2 both exist, so goes into the loop. For value 1, L1 dot value exists, so it's 9, and for V2, L2 value exists, L2 exists, so it's 2. So new value is 9 plus 2 plus 0 should be 11. So current.next will be a new node with 11 mod 10, so it's going to have a value of 1. And then carry should be 11 divided by 10, should be 1. So carry will become 1. And then I could check the next value for the node. So L1.next if L1 exists, which L1 exists, so it's going to become L1.next, in which case it's going to be none. And then L2 next will be to the 1 node. to the one node, and current will become current next, this new node. So it's gonna loop back here. L1 is none, but L2 still exists, and carry is at 1. So V1 is going to be 0, and V2 is going to have 1 because it still exists. The node at 1 exists, and so it's going to be V2 is going to be equal to 1. So it's going to be 0 plus 1, and carry was 1, so it's going to be 2.
Mm-hmm.
Right, 2, and then current next, create new value 2 mod 10 will be just 2, and then carry is going to have carry is going to be 0 now because 2 divided by 10, and then L1 is going to next, if L1 exists, L1 or doesn't exist, is going to be none, and L2 is going to be next, which is none because we're at the end, and current is going to be same as this new node, and after that it's going to come back and check L1, L2 or carry, and L1 is going to be none, L2 is none, and carry is going to be 0, so it's just going to break out of the loop and return dummy done next. Dummy done next.
Yeah, I think it's good. Let's move on to the next question. Good job. Okay, this is the next question. What we're gonna do is, and I want to make sure you hit the right O-Van time complexity, but we're gonna be given an unsorted array of numbers. We need to return the length of the longest consecutive element sequence, and it must run in O-Van time. So, for example, here the longest consecutive element sequence is 1, 2, 3, 4.
Okay.
Therefore, its length is
1,
4.
2, 3, 4, and therefore its length is 4. So, okay, so we are only returning the length. Okay, length of the longest consecutive elements sequence, and it's not sorted or anything. So 104, 200, 1, 2, 3, and 1, 2, 3, 4 will be 4 consecutive length sequence, and that's why we return 4 here. And in this case, I guess it's 0, 1, 2, 3, 4, 5, 6, 7, 8. So 0 to 8 is 9 length, and here is 0, 1, 2, so it'll be length of 3. Okay. And it looks like there can be duplicates for nums as well. In that case, can nums will always have at least one value, right? It's not going to be an empty list. Is that a possibility, or?
Wait, sorry, can you repeat that?
Nums will always have at least one value element, right? It's not going to have an empty list.
It could be an empty list too.
Oh, nums could be an empty list. Okay, then that's probably an edge case. I'll have to check. Nums is valid. I'll have to check that. Then return the length. So in this case, we'll probably return 0 because there are no values. Okay, that makes sense. All right, and since there can be duplicates, I probably want to use a set to put all the numbers into a set, and then by checking if and looping through each number in the set, I can check if the left side of the left number to this current number, if it's in the set. If it is in the set, then I'm not at the beginning of like a number line. I'm not at the very left side. So in this case, using example 1, if I'm at 4, I'll check 3, and 3 still exists here, which means I'm not at the very left. So I can, and then go on. If I check 200, 199 is not in here. That means I'm at the start, and then I can start counting like 200, 201, 202, and then go on. But in this case, it's just going to be 200 and have a length of 1. And then if I get to 1, I check 0. 0 is not in the set, so I'm at the beginning, which means I can start running 1, 2, 3, 4, and then have return a length of 4 because 5 is not in the set. I think that can be a solution.
Okay. That makes sense.
So define the function first. We'll call this longest consecutive length, and then the nums, and return an integer. Okay, so I need to create a set first. So a set of all the numbers in nums, and then for each number in set, if num minus 1 is not in the set, that means I'm at the beginning of the number line, and then I can start counting. So I equals 0, while num plus I is in the set, then I plus equals 1. And then we have return, which is by default a 0. And then result by default 0, plus equals 1. And then result is the maximum of result, or let's see, if I equals 1, if I is 1 and it's in the set, then keep adding. If it's not in the set, then it breaks. So that should be okay. So for each, it's not in, it keeps increasing and checking and returning, and then otherwise return the result. I think that's okay, but I need to do a dry run just to check.
Yeah.
So
Go ahead.
Let's see. Can do the example 1. Try run. So set is gonna have all the unique, just the same numbers, and then it's gonna, for num in S, so it's just gonna start looping through the set. If num minus 1, which is 99, it's not in the set, which is not, and then it starts checking I equals 0, which is in, and then I plus. I guess technically I can start with I equals 1, but I can save a loop. But yeah, so what is it? 100 plus 100 is in the set, and then 101 is in the set, is not. So I equals 1. And then max will be 0 or 1, so it's going to become 1 because it's just 100. And then for 4, for 4, 3 is in the set, so it's going to skip that. And 200 is going to be 199 in the set, and then I equals 1, so 199 plus 200 plus 1's 201 is in the set. It's not in the set, so it's just going to have I equals 1, and result is already 1, so it's still going to remain 1 for result. And then it's going to get to 1. 1 is going to have check 0. 0 is not in the set, so it's going to start counting 1 plus 1, 2 is in the set, plus 1, 3 is in the set, plus 1 and 4. 4 is in the set, and I is going to be 5. 5. I think there might be an error here, actually. Yeah, I minus 1, because when there's four numbers, I to 1 to 4, when I equals 1, and I is going to be added by 1, and that's the one that doesn't work. So if it's one number, 1, and then it's in there, if it's not in, wait, hold on. I might have confused myself here. 1, 2, 3, 4. Is num is 1. And so plus 1, 2, 3, plus 3. So 1 plus 3 is still in I equals 3, and then I becomes 4. And 4 is when it doesn't work. So actually, I know I confused myself and tried to think. I just shouldn't have to minus 1 here. Okay. And then 1, and then 3. 2 is in the set. It's not going to work. And for 2, 1 is in the set. That's not going to work. And that should return length of 4 for result. I think that's okay. That should be okay.
Nice. Okay, run it, like write a couple test cases, just ensure, or run it across run it on these examples and just ensure.
Yeah. Let's see. We can use this one and this one, and we can probably still run the original as well. I think it's run and see, or does it not run if I click run?
Should run. The first one.
9, 3. No, first one is actually this one.
Yeah.
The order is a little wrong. So 4. Okay, I think that's okay.
Nice. No, you're solving these fast.
Now these are like semi done before, but like as you can see, like there's still mistakes with my. I confuse myself when I is 1 or should be subtracted by 1. The little things like that.
Okay.
That throw me off. And
okay, final boss.
Final boss. Okay. Okay. Let's see. F n dice, and each dice has k faces numbered from 1 to k. Okay, k face dice. Given 3 integers nk and target, return the number of possible ways out of the kn total ways to roll the dice. So the sum of the face-up numbers equals target. Since the answer may be too large, returning modulo. Okay. Look at an example. You throw 1 die with 6 faces, and there's only one way to get a sum of 3. So return 1. You throw 2 dice, each with 6 faces. There are 6 ways to get a sum. 1 plus 6, 2 plus 5, 3 plus 4, 4 plus 6. Okay, so the order does matter. 5 plus 2, 6 plus 1, and that's 6 ways. Okay. And then with 30 dice, and then 30 faces, and we want 500, the answer must be returned, and then that's a huge number. Okay. I think I understand the problem. Now I need to think of a good solution to do this with. Not sure if I've ever done something similar to this problem before. Probably not. Return the number of possible ways to do this. Targets. How many ways we can do this and add up to this of k to the n total ways.
You get the question?
I understand the question, but I'm trying to think of a good solution, good method to solve. If I try every possible combination, that's not going to happen. So I'm trying to think, but so if because k is six-sided, which means I get a sum of, for each die get a sum of either 1 to k. So that's the sum I can go with. If actually, yeah, I have a question. Let's see. If there are 2 dice and let's see, target is 6, then it should be 2 plus 4, 3 plus 3, 4 plus 2. Will I get another 3 plus 3 here? So there should be 4 ways. Or wait, not just 4. Obviously 1 plus 5 and 5 plus 1. It will be return 6, right?
Where 2 dice target 6.
Yeah, 2 dice, target is 6, and k equals 6, suppose.
Yeah. So we have 1,
It
5.
should return 6 ways, because 3 plus 3 and 3 plus 3 are 2 different. The order is different, so it gets counted individually, right?
I think so.
Okay.
Wait, 3 plus 3. No, these are the same. These are the same.
These are the same?
3 and 3.
Oh.
Yeah, because one of them is 3 and the other is 3. It's like,
Okay.
well, because one roll, these are the same, no? Like one of them is 3 and the
Yeah,
other.
they are the same, but the first one is the 3, second one's the 3, and then first one's the 3, second one's the. So
Well, the first one here is a 3 also, right?
yeah. Okay. So it will just
I
be
think, yeah. Let's see.
5 then. Okay. So okay. Should I get a sum? Like, I understand the question. I'm trying to think of a solution, and I'm technically drawing a blank here. So not sure how exactly to proceed. Should I get a sum of 1 to k? So if I get k, target gets subtracted. No, that's not gonna. There are 3 ways to do. If I get one for the first die, second die is 1, 3 dice 1. Depending on. Should I given a sum of 1 to k? How can I reduce the number of total possibilities and just add to the answer?
So what would be the brute force?
Brute force will probably be checking every possible way. So like I roll like 1 to k for the first die, and then check 1 to k for the second die, 1 to k for the third die, and then just see until I roll all of them. If the target is like, if the total sum is equal to the target, then I can return +1. That's one way. Like there would be then one way to roll the dice.
Okay.
But that'll
So
be
like roll the first. So you'll just.
after.
So we could explain. So you roll the first dice, and then
Yeah,
you see
roll the
that
first
all the
die.
different combinations, the second dice, can be added with the first dice.
Yeah. I mean, like checking every possible combination until like, and see if the total sum equals the target, and then that will be +1.
How would you generate all the possible combinations?
I'll probably have to do like for loop from 1 to k, add to the sum, add to the total, and then move on to the next die, 1 to k, and then do like a recursion, add to the total, and then third die, 1 to k, add to the total. But that's like super exhaustive and very brute force.
Mm-hmm. What
I think
would your algorithm be at that point?
That will probably be k to number of dice. So k to the n. Yeah, that would be k to the n total number of ways. And because I'm checking every single method. Yeah. Maybe I can reduce the target every time I throw a die, and if I, early pruning, if it's over the target, I can just return and not proceed because I'll be over the target. But even then, that's still close to k to the n ways. If I roll a die, and then how many ways left are there to roll the rest of the die?
I think the brute force makes sense, but it's definitely gonna time out.
Yeah.
So what are ways that you could optimize that sort of brute force approach? It's like a recursive brute force approach. What are like the usual ways that you could optimize recursive brute force approaches?
Recursive brute force, probably, I think it might be dynamic programming. Something like dynamic programming to say, hey, with the number of, no, with that? Yeah, I think, yeah, 'cause like, hey, with the number of dice left, and then this is how many faces it has with the number of dice left, how many ways there are to roll the rest of the dice. So I think dynamic programming can work here. Dynamic programming is like one of my many weaknesses.
Okay,
It's hard to
Go
understand.
ahead and implement out the brute force solution that you mentioned.
Brute force. Okay. Let's see. 3 possible ways. Dice ways. NK and target. Then equals 0. Probably like a backtrack I and the total, then local result. If I equals then result plus if I equals and total equals target. And then I can call like a backtrack of 0 with 0 total and return the result. Oh God. Okay. So I can target, and then I for shade in range of 1 to k plus 1. Total plus equals j, and then I'll backtrack the next dice, and then give the total, and then total minus equals j, and then I can call the next one over and over and over.
What's
I think
J here? Oh, okay, total.
J, I guess J would be the face that it rolls on. So if it's 1, then add 1 to the total, and then I guess this makes more sense. Adds to the total, and then just keep checking until if the total is equal to the target, then no, that's one successful way I get at the end.
Okay, let's run it on a few examples.
Examples. All right, let's try. N equals 2, k equals 2, 6, target equals 7. Then backtrack starting from 0, 0, and then I equals n. I said 0, so it's just gonna continue here. So for j, it'll be 1 to k plus 1. So start with 1. Total becomes 1, and then I plus 1. It's gonna call backtrack, so it's gonna call the next die, and then 2 for I, and then 2 2, and then it's gonna call
It makes sense. Let's
total
just run
1.
it on like k equals 6 or something.
Okay.
Run it on this guy.
I think something would be wrong. Like I'm not checking for the 3-3 earlier example. That might be a problem for excessive. Oh wow, excessive output. Did I check for? Oh yeah, if total is greater than target, I need to get out. So that should that gives 6. But I think it's gonna it might fail for this one because 3 and 3 they count as 2 separate. So if I run 266, it gives 5. Oh wait, no, yeah, this one takes care of that case. Okay. But yeah, this is the backtracking worst case scenario brute force. And then I'll have to, not sure if I can think of a dynamic programming way to speed this up.
Yeah, let's see.
Like, what would be the usual way you would approach this?
Well, you'd want to start cache like when does it start repeating sub problems? When will it? What are the different sub problems? Like, I'll give you a hint. What will it ever call backtracking with the same exact parameters?
Backtracking with exact same parameters. If total is the same, but if total is the same, and then I guess they're the same number of dice left to check, then it's gonna do the repeated work, right?
Yeah, like anything. Basically, just try to figure out where work is being repeated, and if you can cache that. Cache that is just build a hash map with maybe the key is the cache key, and then store it with that value, and then probably somewhere here. Check cache. Because what's taking a lot of time? This backtrack right here.
Right.
So if somehow you don't have to check that.
Okay.
Like you don't have to go all the way down.
It would be like dp of I guess something like I or j, and then or I, and then I guess total, the new total, and then that would be the key, I guess. Right.
Mm-hmm.
And then I have to, like, the first time I do it, then I save that value, and then I can just, hey, if that I total is in DP, then just, I guess, return that. That'll be faster.
Yeah.
Okay. So that's the approach that I have a hard time like converting a problem that's like brute forced to a DP solution. Okay.
Yeah. Since we're pretty much out of time, I'll share what my solution would look like.
Okay.
It's just kind of similar.
Target. So you would then backtrack. Oh, okay. So
all you need to do is just cache.
Run backtrack, but this is where you find it. If it's already there, then when it runs backtrack, it gets that, and then you save it because you finish running here. Okay.
Yeah, I'll be like, if we have 5 dice left and we have the target, this is the result. So if we ever see that again, if we ever get the input that we have 5 dice left and the target.
5 dice left. In the
Like,
okay.
yeah, we're basically just caching some of these backtracking calls.
Would target be this? Oh no, you're calling, you're changing target here. Okay, yeah, that makes sense. But okay, I need to think about that kind of approach in an actual problem. Okay.
Yeah. Overall, pretty
This-
good. Like, you
this is
solved
a-
3 questions. Or, yeah.
Is this a medium or hard problem
Medium,
for the
medium.
dynamic programming?
It's a
It's
medium.
right? Yeah.
It's like boilerplate dynamic programming.
Uh-huh.
Like, you could see, like, you almost were there. If you just add like 3 extra lines, you're gonna get there.
Okay.
But with a lot of DP questions, it's that simple, where you build the backtracking and then you just figure out how you're gonna cache it. You can see
Okay.
mine is very close to yours, but I just cache it.
Right.
So once you get it working, just practice a bunch of DP questions, because Google likes to ask DP questions.
Okay. I think Google likes to ask DP and graph, these 2 type of questions a lot.
Yeah.
Uh,
But yeah.
okay.
Cool. Thanks for hopping in. My eyes are burning, so I'm gonna go eat.
Oh yeah, you've been like on for like so many hours. Thank you so much, James.
Yeah.
Like, take a break.
Good job. All right. Catch
Yeah,
you.
thank you so much.
See ya.
Alright.
Peace.
Thank you. Bye.
Yeah, Paul, I'm gonna message you. Yo, Paul, did you book? Yo, Paul, hop on my. Let's do tomorrow. Yo, what time are you free tomorrow, Paul? We can hop on a call. Yeah, you're on Eastern time then, huh? Shit. People already cracking down on Cluey. Yeah, Cluey got cooked. Do you review resumes? You're getting shipped out to Dagestan? Yo, that sounds like a good place to be. You can go hang out. Is that where Khabib is from? You can go learn how to wrestle. Yeah, I can do resume reviews, bro. Just send me your resume to... Send it there. Or no, sorry. Let me get it right. But anonymize it and stuff. Let me redact this. Okay, let me answer that, Rex. Yo, Rex, just hit me up too. What is the key for learning to resolve exercises in LeetCode? I broke my head thinking. The key is practice and start from the basics, build your way up. The person that I interviewed solved 1,000 LeetCode questions, so if you see him thinking about solutions you can't think of, it's because he has a lot of practice. A lot of the people I've interviewed people from like 0 or 50 LeetCodes to 100 or 1,000 LeetCodes. And you'll see the difference. The more you practice, the better you get at it. It's all about practice. Rex, hit me up. Hop on the Discord or email me and we'll talk about... I can help train you up. For sure. Holy. Okay, we got more. I'm going to be streaming again tomorrow and the day after. I was on vacation, so I need... That vacation is expensive. So I need to make my money back. My plans... Paul, when exactly is your interview? What day? And what are they gonna ask you? Did they say? Like, or what do you predict? It's not LeetCode, right? 5 Python? What do they mean by 5 Python? Okay, you're fine. You're fine. Yeah. You're good. You're already expert at Python. Yeah, you're good. Just like just spam GPT to ask you. You can use GPT so good for that. Be like, generate me 5 Python questions, answer them. Generate me 5 more, answer them. And just do that for like an hour each day. For sure, yeah. I don't want you to get I don't want you to get like not be able to get the job just because you told me. Let's see. What else? I'm literally killing 5 more minutes so I can label this. So I can label this this YouTube video 7+ hours of coding interviews. Then I'm gonna go eat. Bro, my neck hurts and everything. My eyes are burning. I need to learn how to split these up into 2 parts. Maybe for the first part I'll stream on YouTube, then like for the next 3 hours I'll stream on Twitch after like a small break. Something like that. Yo Rex, where are you based in Philippines? Yeah, I'll throw the Twitch link. I'll throw the Twitch link. I don't have Twitch yet, or I'll show you. I made like a crappy Twitch. I haven't streamed on it yet. I don't know, just to reach different people. Some people are only on Twitch, Paul. Not for the money or anything. I think just some people. Yo, Orca, my eyes are burning. Sometimes I've done 12-hour streams before, but I spaced it out a little bit better. Really? I'm gonna try it up a little bit. Yeah, I might get on Twitter. We'll see. Dude, there's like a lot. There's a lot of different avenues. Dude, there's so much. I want to get on all these, but at the same time, I don't want to run it myself. I want to focus on my job. So, what I'm planning to do is. Oh, from Hawaii. Okay, what I'm planning to do is yeah, like if I can make enough money on my job that I can pay someone to run my Instagrams and TikToks and stuff, I'll rather do that. But other than that, I'm lazy. But yo, Paul, double your TC. You got this, man. There's no way you're gonna fail those interviews. The way that I seen you perform, but. Hell yeah. Alright, I'll catch y'all. See you next stream. Probably tomorrow or the day after. Peace out. Have a good night. Happy Sunday.